Okay, can you see my screen?
Yes.
And how is the text size in this window here?
Small for the back of the room.
Okay, here I'm going to bump it up a little bit. That might be a little, how's that?
Maybe smidge, but maybe a little more.
Here, I'll try one more. And yeah, I think that should work. This might be a little excessive, but we'll see. Who needs files anyway? That's actually a good question. Do I need files? Okay. So this is that I'm sharing right now is actually an example that I've prepared for just quick testing of Sparrow loading data. And so I actually pasted 3 links in the Zoom chat. And the first link that I pasted is a link to the GitHub repository that contains this example. So this is something that can be followed along with on your own from that repository. So I'll actually paste the link directly to the, well, the README shows up in this GitHub repository page that you go to, and you can actually go to the code notebook file within that. And it takes a little while to render, but it will show kind of the process that we're using here. So we're going to do a quick demo first of loading data into Sparrow, or preparing data for loading into Sparrow, and then do a demo of actually installing Sparrow and loading data into a real Sparrow instance. So what I mentioned in the presentation on Sparrow earlier was essentially that Sparrow takes any type of lab data with a broadly geochemical organization. So samples, sessions of analyses within samples, measurements within those sessions, and then individual data points within those measurements, and can import that data into a schema that's customized to that lab. So the way that we do that is by basically importing data that conforms to specific data schemas that we can test in advance to see if the data will fit into Sparrow. So I'm going to follow through on this code notebook here and basically run an example of how to import data. And I guess with the text this big and the screen this small, it is a little cramped, but I think it's okay. So actually, let me bump it down one size. So the first step here is we're going to install a Python library, which is called Sparrow Loader. And this is available publicly. So if you're running Python, you can just type pip install Sparrow Loader. And it'll take a little while and give you some output, which is truncated here, but it should install it. And then you have this Sparrow Loader module in your Python installation. And so I can import 2 important functions here. And one is validate data, and the other is show loader schemas. So I've done that now. I've loaded these 2 functions into my Python environment here. So then we can show the loader schemas, and it'll become clear what that means once I do that. And so this is a whole list of data formats, essentially, here. And so there are blocks of data that Sparrow can accept. And those blocks can be prepared by parsing an Excel sheet or parsing an XML file or manually entering data or any other way that you would want to prepare kind of an object with certain properties. And those properties describe a specific chunk of data in a fairly general way. So here we're seeing a project schema. So a project has a name, it could have a description, it could have a date to which the project is embargoed sometime in the future. It has a location name and a variety of other pieces of information. And then there's also, here is a sample schema, which has fields like name, universal unique identifier, IGSN, another format for a different lab ID, also some fields about location, elevation, depth, embargo date, etc. And so that's kind of the format of a specific piece of a information that can be loaded into Sparrow. And so this is kind of a guide for how a data set needs to be prepared to pull into Sparrow. So we can show the schema for a specific data format as well, rather than the whole collection of formats. So then what we can do with this little Python library, without having to install Sparrow, the full installation, which is a little weighty and requires this Docker, which is a pretty big piece of software, is we can validate data. And so we can test whether the data will be imported into Sparrow correctly, and then appear in the Sparrow database. And so this is a very simple sample object, which is just it's a Python object that has a field that's called name, which is a test sample, and then it has a named location, which is very non-specific. And so what I can do is I can run this validation function and say it will, if everything is correct, it will return a sample object in Python. And that's an object that Sparrow would then go and insert into the database to track for a lab. Now, if we do something wrong and we say we have a sample named test sample v2 and its elevation is just in the sky, we can validate the data and it's going to throw an error. And the error that it says is elevation is not a valid number. So you need to provide your elevation in meters or else it's going to be upset. So that's very, very basic. You know, there's not a lot of value to recording a single data point like that, but you can record a lot more complicated data into Sparrow by importing data that has nested attributes. So each loader schema can nest other schemas within it that allows you to kind of explore the full scope of a data set. So here's an example that's a session. And a session is kind of a group of measurements on a single sample that are grouped in time. So you'd think of like zapping something on an electron microprobe as being a session. So within session, we can nest other schemas, and this got truncated due to the length of this response. But we can nest analyses and we can nest data points within it. And so if we have a simple session, we can nest information about the sample within it and verify that we can import a session that has a date of January 1st of last year and is linked to sample 1. That will work. The same thing applies where if we say the date was last Monday, well, that's not good enough. It needs a specific date. So it says it's not a valid date time. But the nesting functionality is where the import really gets useful, because you can take something that is a session of measurement and it has individual analyses within it. It's linked to a sample, and then it has a collection of data points. And here, for simplicity, there's only one data point in this sample. So this is a sample that, or a unit of measurement that was done on a certain date that was using an analysis type of soil aliquot paralysis, which is just something that I made up. I don't think that actually exists. And it has one data value, which is 1.18 plus or minus 0.15 weight percent of water content in the soil. So that's just an example of importing a single piece of data into Sparrow. And basically, you can validate that that works, and you can import data of that type. So that's all to basically ingest data into a database. And it's very simplified. I guess any questions at this point? Cool. Well, this is basically how you think about data to put into Sparrow. Is you're going to take the data formats that are produced by a lab and pull them into this pretty tedious but pretty descriptive nested format. And then there's a tool to validate that data to see whether it would fit into Sparrow. And so this is purposefully made very flexible to handle all sorts of geochemical data and associated metadata. So that's kind of the first step. The more interesting part is, okay, say that we have a set of data that we'd like to import. We think we have the ability to create this type of nested hierarchy of data using Python. Can we actually put it into a database that allows us to manage that data in our lab? And that's where running Sparrow, the Sparrow application comes together. And so let me pull open the file explorer here. So in this process, the first thing that we need to do is install Sparrow. And so the third link that I guess the second link that I put in the chat is actually the, sorry, this is a better way to look at this. The third way, or sorry, the link that I put into chat is a link to the Getting Started guide for Sparrow. And this basically takes you through the steps of installing the Sparrow data system on a computer. Typically, the first way to install this is on your own laptop or something, but eventually you would scale up to a server in your lab or at your university data cloud. And the biggest piece of this is installing the Docker application, which is it's an application framework that allows you to run different components of an application without actually having to manage all of the code on your machine. So you can pretty quickly scaffold Sparrow, which is composed of a database and an API and a website and all of these different pieces. And it all comes together very simply using this application. So that takes a little while to get set up with, but we're going to skip that. And we can just progress right to installing Sparrow itself. And Sparrow is available online as a kind of installer using by downloading it from this Git Sparrow script. And so here, I'm going to open a terminal here and clear it out. And then what I'm going to do is type this command, which is the Sparrow download script. And basically it's going to say, okay, we're installing it on your machine and it's going to write an executable. Would you like to continue? And you provide your password, which I just mistyped. Nope. There we go. So now it's downloading Sparrow, which will take however long it takes. It's not that large. Okay, so we installed Sparrow. And so when you install Sparrow, then you can run the Sparrow command to test whether that was a successful operation. And so that prints out a lot of information about managing a lab instance of Sparrow. And what it shows here, and actually I skipped ahead a little bit because I'm in the directory loader test lab, but if I run this from outside of the lab, it will say, well, it will pop up some information that starts with no lab configuration file found, which is the default state of Sparrow. is to not be configured for anything. So you can still run an instance, but it won't have the ability to collect any data and manage it over a period of time. So the way that we move forward from this is we actually go into a directory. And this directory is actually included in this demo repository. And so I'm going to open this file explorer here and just look at a few of the files that are in this directory. And so there's a README, which basically says this is a testing lab for Sparrow. And it has only 2 other files, and it has this config file, which just basically has some default configurations, the name of the lab, and then where we can find loaders for data. And in this loader for data directory, we have a very simple set of Python functions, which basically are called load test data, and that's about it. So, and then there's another one that's for printing out information. And then we have this test data set here, which is a much more fully formed version of data that was actually exported from Sparrow that shows nested data about a single publication set of samples from the WSCAR Argonne lab. And so this is kind of a deeply nested data structure, but it has a very repetitive set of data parameters and numbers associated with this set of Argonne measurements. So we're going to eventually import this into an instance of Sparrow. So I'll open my terminal back up. And now that I'm in this test lab, I'm going to run, increase the size a fair bit. And I'm going to run Sparrow again. And it's going to show me that I am in a lab named loader test lab here. And it's got this configuration file, and it's got a lot of key commands here. And the most important command is up, which starts the system and starts the database and all of the associated components. So I'm going to run Sparrow up here. And this is a process that the first time it runs, it has to download a lot of components of Sparrow, which are somewhat large because they include virtual machines that actually run the different pieces of Sparrow. So this can take a little while, especially if you're on a slow internet connection, but it prints out a ton of info once it's done that basically says, oh, it's coming up, and here are logs, and we can exit out of that. And it gives scary messages, but it's still running. And then we can do another important command, which is Sparrow create user. And that just allows us to create a user so we can log in to manage data on this new instance of Sparrow we're creating. And I guess I did this too early because it needs to initialize a database, essentially. And usually it does that automatically, but it might be because I already ran it and it has some sort of database. So let me try this one more time to see if it. So I'll run Sparrow init. So what I'm going to do here is reset up the Sparrow database on the off chance that some wires got crossed in this test lab instance. And so this runs a lot of scripts that basically create different tables in Sparrow's database schema. And so then I'm going to run Sparrow create user again. And now it says enter the desired username. So that's test, I'm going to say, and then the password is also going to be test. And this is an example. It works fairly well in this framework, but this is an example of one pain point in Sparrow that exists because we currently only have the ability to create new users from this command line interface. And the more ideal way would be to have a web interface for that, but that's something that we're working on. So now we have an instance of Sparrow with a password and a user in the database. So then the question is, what does that look like now that we've booted that up? And I am going to go now to this localhost website, which is localhost is just a mnemonic for running something on your computer locally. And so now we have an instance of Loader Test Lab with a website on our computer. And it has a data catalog with all of these entry points for project samples, sessions, and data files. It has a map of the world that is currently empty that will, hopefully show samples on it. And we're not logged in, so then we can log in as test and then test. Huh. Boy. Apparently my password is invalid, which means I do not remember it. Okay, let's try with a different one. Okay, let me try stopping Sparrow. We're going to restart Sparrow and see if that helps. And in the meantime, we're going to take a look at Sparrow's database because we have the ability to do that. So Sparrow is running in a database on my machine now that I've spun it up with these commands, and it has a ton of tables in it for holding information, all of which are basically empty because we have, oh, and it just restarted. So, but we have a bunch of empty tables. The only table that should not be empty is the user table. And we have a user called test and a user called test1 here. So the users were inserted into the database. So that's good, at least. And then I'm going to go back to our website. Let's try to log in one more time. And if this doesn't work, it's probably an error with this version of Sparrow. There we go. We've logged in. So apparently we have to restart the server before we can log in the first time. But what we can do now is we can go to this admin panel, which has some more options for how to interact with Sparrow. And it has still these links to projects and samples and sessions, but there's nothing in this because we haven't loaded any data. But there's a panel called tasks that has the ability to run different analytical tasks to import data. And one of our tasks is called load test data. So let me make this a little larger so that people can see it. So we have this load test data panel, and we can actually press start to run this task. And we're going to get some output that's basically a copy of this data object that was in our folder. And then the notification that says task finished. So now that the task is finished, we can go back to our projects list. And now we have a project in Sparrow. And this project is focused around a publication. So it's named as the publication title. It's linked to this publication with the DOI. it has two samples within it. These two sessions of data, and then each of these sessions are linked to a sample with a location, and they have information about sample heating steps within them. So this is a data set and a way of organizing data that's focused on argon information, but all of these heating steps were assembled from just the organization of that nested JSON object that we can look back at in a second. But these are organized basically by the preferences of the lab for how they should show their data. Different heating steps, the general information about the sample, and then the final measured age. And then the nice thing about all of this is that I can go into a database management environment, and I can actually see the same information in a standard PostgreSQL database for my lab. So this is the project, which just has a title, but then it has links to publications, and then there's a whole list of data values, 200 data values that were imported from these few samples that are linked to different analyses and data types and that sort of thing. And now I can do things like select star from, let's see. Selecting all of the data points that we've measured, and then I can select all of the data points where parameter equals step age, for example. So this is, I'm just selecting all of the ages in my database. And so this is only one small set of samples that we imported using one Python function and one static file, but you can imagine that if you were able to create a Python script that iterated over the data archive of your lab and all of the Excel sheets or other formats that you had data in, and imported the data in all of those, you could create quite a large store of data spanning the archive of your lab relatively quickly. So, and then that data could be explored on a web interface like this. And this web interface then can be customized for different labs as well. So that's kind of the process of getting set up with Sparrow. And as a data archive gets more complicated, with more data types, there's more code that's required to actually get the data into a Sparrow instance. But there are a lot of labs that have built test pipelines and pipelines that are actually in production, and all of that code is public, so it provides a starting point for writing more complicated import plugins. But for example, this is a one from UC Boulder, and they have different Python files that have basically processes for ingesting spreadsheets from their data archives and putting them in a Sparrow appropriate format. And that's something that was developed over several months by a postdoc at that particular lab. So that's the basic process of setting up a Sparrow instance. So it's pretty easy to test out and play around with, but the building these loader pipelines to actually deal with real data is the big challenging part here. But you do get a lot in terms of being able to put your data on a map and have it accessible to further informatics resources relatively quickly. Yeah, so any questions on that demo? I think that's about all I've got.
Online, in person.
Oh, sorry, I couldn't quite hear that.
I think we're overwhelmed.
Yeah.
That's a lot.
But I guess the way to think about what we just saw is the end user, you probably will never be facing this building plugins and compiling Dockers. This is perfectly appropriate sort of task for system administrators in the lab. But ideally, you will never have to deal with any of this, but you can build customized environment. The question I have is, can you put all these things somewhere in the cloud? Because I see you have a server running in certain ports, so you don't need to really build it for every lab, right? You can just
Right.
which we don't.
Yes, so the answer is this can definitely be deployed in the cloud, and it can be deployed on anything ranging from a single server that sits physically in a lab to, you know, on a cloud virtually hosted server. And actually this, one of our biggest installations, which is for the Arizona Lasercron Center, which has thousands of samples, and they're indexing, I think, 700,000 detrital zircon samples in their archive, or no, 700,000 grains right now, is actually hosted on a virtual server that they pay $20 a month for on the cloud. So that's one possibility. The reason that these servers are kind of, even when they're hosted on the cloud, they're kind of individualized to the lab, and that's because this is really mixing data from different labs with totally different approaches to managing data would probably cause more problems than it solved. So what we focus on is building a good framework that can be applied quickly to different labs, and not, you know, not really shared between them. But one thing we're looking into is kind of having an organization that manages multiple installations of Sparrow for multiple labs. So at least the informatics part and the kind of sysadmin aspect of it is handled. And the labs really only have to focus on their data. Because yeah, the one challenge is getting it running on a server in an effective way. And that's one that's most appropriate for sysadmin. But the challenge of how to build data import pipelines, you know, and Python scripts that import the data is really one for somebody who has a lot of familiarity with the data process in the lab. And the most effective people at this have been grad students and postdocs in the lab who have some level of Python skills, although people have written importers in R, and it could be done in MATLAB as well. So, you know, having some skill with understanding the data is important, especially because a lot of the challenges that you run into in devising this process are like, oh, there's these two different ways of accounting for error. Which one is the one that we should carry forward? Which one is the, you know, like how do we solve these standardization problems and that sort of thing?
I think, like, if you look on the number of cases you have, you all came up with a pretty small number of deviations, because in reality, all geochemical data very simple, right? You have something that you're measuring, you have the uncertainty of that measurement, and maybe number of measurements, and that's it.
Right, yeah, and that's kind of the key part of this, is because the metadata style that all the labs need is very, very similar. And the difference is really just in what the field values are and how they're organized internally. So, you know, this argon lab has heating steps, and another geochemical system is going to have instead like microprobe points, or, you know, somebody else has different you know, degassing steps or something like that. There's multiple ways that the measurement is done. But just as long as you're able to like nest data in different ways, the fundamental building blocks of sample analyses, data points, and then project and publication information are very similar. So there's a lot of commonality at the metadata level, even if there's not a lot of commonality at the analytical data level across all of these fields.
I have a question about, you know, a vision for this, like something like I'm thinking about laser ablation data where we have for every analysis, a time resolved analysis file, or in case of many files, and a script that brings those in, and then that you manually have to interact with to select an interval that it integrates over.
Yep.
And then that has an output, and then that output is linked to a bunch of standards, and that produces an actual concentration table, which goes into EarthCam or other outputs.
Right.
is this basically a way to maybe link that script that you have written to process the raw files to the published output? So if then you look at that, or not published, but your final concentration, and you say, oh, one of those analyses is funny, I want to go back and look at the time result analysis and link it to the actual raw data. Is that the idea here? Is in a more
Yes,
complicated example?
Yeah, exactly. And so in the example that this example lab, there's this tab called data files here. And it's empty because we just imported structured data that wasn't linked to a file. But in a more complicated Sparrow instance, you actually basically say, this is the file that I'm importing, and this is the data that I'm pulling out of it simultaneously. Because part of the point is that it actually indexes the file and tracks it internally.
Sure.
And so it has a directory full of data files that it manages then. And then you can actually go back to the specific Excel file or whatever other file that was the baseline for this analysis and see exactly which file was used and then exactly what parameters were put on top of the file by the lab process. And in the future, we're hoping to add things like flagging different levels of data quality, like maybe the lab wants to notify for data that's older than 5 years that like, oh, we found an error in our pipeline and, this one data value should be trusted at a lower level or something like that, like being able to propagate those things forward. But in a more like in use instance of Sparrow, there's a whole list of Excel sheets, and this is actually thousands of Excel sheets covering the whole range of the data archive, and those link into the samples and sessions as well. And you can actually download the Excel sheet and look at it from Sparrow. So that's really one of the big pieces of this, is it actually provides a way for you to go look at your data in multiple ways and then track it back all the way to the source file. So here for example is this data file actually or this sample actually has a session of measurement, and then it's linked to a data file. So if I go to this data session in the Argonne lab, which is on an older version of Sparrow that runs certain things very slowly, but basically this session has a step heating analysis, and we've actually integrated a nice little chart in here that shows the analysis in kind of an Argonne lab friendly format. And then also has the tab where you can see this more standardized representation of just numerical heating steps and age plateaus. And then this also here allows you to go look at the data file and then download it from that place. So it's kind of a way of fusing those different representations of data, the original representation, and then the database centric representation of data together, so that any further iterations that get linked into the community ecosystem can be tracked back to the source.
So it's really like, it seems like it's most like elegantly set up for dealing with something like Argonne data, or maybe laser ablation data, where you actually have a script or a kind of an open process that goes from voltage to end result, concentration or age, versus something like, I'm thinking like microprobe data, where people typically use either the Joule software or probe for EPMA. So in that case, with more the black box software, does this basically lead you to that endpoint of, you got this out of this processing software, that's the raw data point?
Right.
And that
So
would be kind of the start of the journey.
Yeah, so the way that tends to work is you're absolutely correct that when you have a kind of user interactive analysis and reduction process, that's something that this does not include. So basically, the easy way is to just start with the endpoint of whatever the reduction process is as the data outputs. The secondary step that this kind of hopes that processes will evolve towards in the lab is basically, there's no reason why you can't have two separate import processes for the original raw data coming off the machine, and then the reduced data that's is after user inputs, and that can all be stored kind of in the same, just as long as everything's stored in the same file area. So generally, what we encourage lab storage is having one large like file volume that they organize internally fairly well into, like, this is pre-production data, and this is reduced data. And then Sparrow can import both of those and link them together, so you can see both the reduced data coming off your reduction platform and the pre-reduction data. And then the hope is eventually that Sparrow can integrate in some way, like extensions can be built so that maybe that data handling of passing it off to the reduction platform and then bringing it back into Sparrow can happen kind of in an automatic loop. And that's what I was referring to with this Colorado lab that did it for thermochronology. Is they actually evolved from having a process where they had 3 separate spreadsheets coming in from different instruments to a process where they had raw data files coming in from 3 separate instruments, and then a Python process that allowed them to reduce it, pulling data out of the database and reinserting data back into the database directly. So that saved a lot of time of trolling around directories and finding Excel sheets in the end.
Okay, sounds great. Thanks, David.
Okay, yeah, thanks very much for following along.
Thank you. Okay, we're gonna switch things up a little bit. Trying to keep with the workflow, but also because things have been getting modified today all morning. So Kirsten's gonna save the Earth Chem data repository part for tomorrow. So she'll do the introductions and the guided hands-on tomorrow. It should all work out fine, and we're running into really late hours for some of our presenters in different time zones. And so we're going to now, we changed virtually, the agenda online is now is updated. So now we're going to move into the guided hands-on for sample registration with CSAR. And have you seen it?
Says, are you on Zoom? Let me get her
Yes,
on.
I am on Zoom.
Oh, you are?
Can you hear me?
Yay.
Okay, great. Okay.
Yes. Awesome.
Sounds
I
good.
don't see you. Do you need to share your screen, right?
Yes, I'm gonna share my screen. I'm guessing I don't need video for this since I'm sharing my screen. Probably easier that way, right?
Yeah, but introduce yourself. That would be nice.
Okay, sounds good. So give me 1 second. Let me start my presentation, or give me a sec. Hope everyone had a good flight while I'm doing this.
Most of us have got here.
All right, so hope everyone could see my screen. Oh, there we go. Can you guys see my presentation now?
Yes.
Okay, not the presenter slide, the presentation. Okay. Yeah, the dual screen thing sometimes gets me. All right, guys. So hello. I'm glad everyone is there safely. My name is Sabiel Choi. I am the CSAR curator. Unfortunately, my presentation isn't as interactive as the other one, but I'm sure we'll all get through it very nicely. So I'm going to do a brief demo on the CSAR and how to use my CSAR and register samples today. We are going to cover 3 topics: how to access my CSAR, create an account, and register a batch. Just to let you know, the regular site is for registering real samples. We're going to use a testing site, which is the one down here, app-staging.geosamples.org, in order to test so our samples don't get registered with real IGSNs. All right. Give me a sec. So to access my CSAR, which I hope you guys all have an ORCID account. If you haven't created one, please do so right now if you have, or a little bit later when you're actually ready to start testing the demo. So again, we're going to use the app-staging geosamples.org as a testing site. We do also have a GeoPass login. However, this is really reserved for web services and we don't really use it. So we're not going to cover that today. So once you log in with your ORCID, you have there we go. You're going to be directed to the My account under My Caesar. So this is the first page that you actually get to before you do anything. So you want to make sure that your first name, last name, and your institution, email, and country is all recorded. The Caesar should directly take your first name, your last name, and your ORCID from your ORCID account, but sometimes it's not done correctly. Just make sure, and if it is not done correctly, just update the user profile. I'm actually gonna give you guys a minute to do this if you guys want to follow along. Is that okay, or do you guys don't want to do that? Anybody in the audience? Okay, well, so without this account, you won't be able to do anything, meaning you can't actually register any samples or create a user code.
Saves?
Yes?
Can you hear me?
Yes, I
People
can.
want to follow along, so we have to go a little slower.
Oh, okay, that's good. Sorry, I can't really see anyone, so thank you. So yes,
That's the disconnect in the virtual world.
yes, I'm glad you're giving me the advice. Okay, so everyone, if you can, please go to the site up here. If you see my mouse, http://appstaging@geosamples.org. And you should be able to log in with your ORCID if you have created one already. And just let me know when you're finished with that.
But are these accounts then permanent?
Well, this
Because
is a
it's
test.
staging.
Yes. But we probably could talk to Sean about deleting them if we needed to. And again, these won't be real samples registered with IGSNs. They're just testing instances. So nothing is officially going to get real IGSNs. That makes any sense. It should.
Oh, I'm totally confused.
Huh?
We were just using a test environment.
Yeah.
It will
Yeah.
look like it's making IGSN, but it won't actually make any real.
Yes. So
Okay,
basically what
So
happens
we're
is
not
that,
testing.
huh?
If you want your account to be permanent, you can go through the real production system. We just didn't want, to get a lot of samples into the system that we then have to delete because they were fake. Right, that was.
Okay, now it makes sense, sorry.
Yes.
That's
That-
what-
No, I
that was the
apologize for
reason.
not being
But
clear.
the account, the account can be done on the production system because you want to keep it.
Yes. So your real account will be the production, which will be accessible on My Caesar button in the front of the GeoSamples webpage. And anything registered there will be sent to me as a batch and approved for real IGSNs that will be resolvable or individual samples.
Is it possible that if I had a account before using a GeoPass, when I log in with Forset ID, I get into a different account?
Yes, you can. But we could talk about that later because that's a separate instance, which requires a little bit more guidance.
Or if it links to your GeoPass.
No,
It doesn't.
no.
It doesn't necessarily do that, which is why we need to do another thing. That's another step we got to do some other time that I don't want to go into right now because that's complicating everything, if they don't mind.
Okay.
Just give it 100%. Yeah. Wait. You the point, but. So, yeah. So I think some of you may be at the stage where it asks a user code.
So should we move
and-
on?
I don't know, maybe we should stop where she's at, she just wants to hear it.
In my profile, yeah, no, sorry. You need to make sure that everybody has their profile. it's difficult to do this.
Don't worry.
Of course.
We want to do this. So I think Cheryl would get very mad at us if we went and did this ourselves.
You're doing the big one, yeah, yeah. Yeah, I mean, that's. It's. Everybody there? Okay, since we can move on to user
Sounds
code.
good. Thanks for the cues. I appreciate it. So once we actually have and set up my account, we are going to go to the add delete user code, which I'm sure most of you have seen now or have kind of touched upon. And this is where you're going to add and create a user code. So your user code is any 3-character comprised of letters and numbers. You could use any combination. However, what happens is that if you use a user code that someone already has, you get this error saying you have the code you have entered is already in use. So you need to make a new user code. So I'll give you a minute to do that.
What should we base it on? Our name? So what is it?
Yeah, a lot of people use initials, but there are people who use 333 or whatever you feel.
And this is all of your samples will always.
It's a lab by
Yes,
technically,
yes.
lab by, mine's BLF for big and city.
Adam to.
Because that's gonna be
I
some.
just said MWL, so.
This is actually a good time maybe to go back what I mentioned earlier today, this change that has happened with the IGSN. When the IGSN was created, this user code really was what made the IGSNs unique. There was, you had a user code and you could have any kind of, string after that user code, but because the user code was unique and that was guaranteed, number would always be unique, right? Situation in that we topics, I really have an example, but you know how a DOI looks, right? So you have in the front it's doi.org and then / and then there is a number, a 10 dot some 5-digit number. That is a prefix called a namespace in the handle system that makes the DOI unique. So that number pertains to your library, for example, or it is a data repository and so on. And then after that / after that number, you have a string that the library assigns to that DOI. So now there is no more registration of these user codes across all of the IGSN allocating agents. This is now internal to CSAR, and CSAR will make sure that your user code is unique. And we will always find the samples within CSAR, but that namespace of the handle is now every allocating agent has their own prefix and the namespace and can do with the suffixes what they want. So even though the chances are very low, there is a chance that the suffix can be repeated, that somebody
So
else might have.
some other registrant somewhere else in the world, so they might have a user who puts in the same
Yeah.
numbers as CSAR did.
Right.
Right,
So I fought with everything I had against this move. And it, the operational environment at DataCite basically demanded it to go this way.
well, otherwise they would have had to basically had every registrar system be able to poke at every other registrar system when it was there.
And that's why systems like this Internet of Samples are so important, because they will still aggregate the metadata across all these different agents. It's no longer the CSAR metadata that necessarily helps you with that. So that's the big change, and that's why it's kind of confusing that we're still asking for the user code. But I'm hoping that, or I'm intent to make sure that CSAR will still work for you by just using the suffix in the IGSN.
IGSN through CSAR. The CSAR number, which is a suffix,
It's
plus the code for
That's the
CSAR.
code. So CSAR is now 10.5802, whatever. In the old days, every IGSN had the same prefix.
So what happens with the, because we have a few publishers that started putting.
All the-
Into the publication.
That's taken care of.
Okay.
All the old numbers now get re-registered, and CSAR is just starting that process. They all get re-registered and exist twice, so there's an aliasing from the new DOI, it just aliases to the old one and it still resolves.
Okay.
So every old number will function the way it always was. It's complicated, it's way too technical for.
So I guess
For
we
me.
all gonna use your code.
Okay, user codes are done, 6.
All right, just to let you know, the user code you make in here is not going to reflect the user code or the account that you make in the production site. So they're going to be completely separate, okay? So this is more important for later for the exercise, but I'm going to go through it now. So after you're done making user code, you also have the option to manage your user code permission. This means whoever you want to give your user code access to, meaning your fellow researcher or a lab mate, or if you're in a bigger lab, the people who work there registering the sample, can use the same user code as long as the person who made the user code gives them authorization. There are different levels, and you could do read, you could do create, read, edit, delete, which is the highest permission setting. You also have the option to set how long the person you're giving the access to, they have access to the actual code. So if I set it for up to February 4th right now, I can only use it up to that date. If you need to use it longer than that, then the person who's giving you the access code needs to redo it. And once you do this, you'll see this at the bottom where it says view, update, delete current permission settings, and you have access to following user code from other people. And it should be updated there. Again, this is not as important right now, so we'll come back to this when we're ready to do the actual demo, okay? Good?
Yep.
All right. So this is the individual sample registration. We're not going to cover this, but what Kirsten was just talking about right now is this prefix over here, the 10.82274. And you can see this here. So this is what happens. This yellow box is a sample landing page. This is what you'll see once your samples are actually registered with the IGSN. The 10.82274 is just a code that we have as a pretend prefix for the testing site. It's not the actual CSAR prefix. Important to note. Good?
Yep. So just to say, I mean, if this individual sample registration is used very rarely, but if you just have 3 samples and you want IGSNs, you might want to use that to type the information into the form, and you get the number right away. When you upload a batch, it has to go through SAIS.
Yes, so the batch registration always goes through curatorial review. And as Kirsten said, the individual sample registrations do not. And you also have the option, if you ever do, create your own or let CSAR create the IGSN for you. Okay. All right. So let's move.
Where
Yes?
do you go for how do you get to individual sample registration? I don't see that along the top.
I'll get to that. I'll get to that in a minute after I go through the batch. I wasn't gonna do the slide, so.
I'd like to add one comment. I think maybe AVO did this. So this does give you the capability to essentially make a bunch of IGSNs in advance. You could make 50 IGSNs and then write those on your field banks as you're collecting the samples. Because you already control those numbers if you wanted to do it that way.
Yes.
And then add that information to CSAR later. And but you could, that way your samples could have the IGSN on them from the very beginning and it would never need any other number.
And the label with the QR code.
Yeah, you
on
could,
it.
true, you could print out the QR code things and stick them to your sample banks. When you're collecting the samples.
If you do that, please make sure to actually update your sample metadata, because we do have users who forget to do that, which is an issue for us sometimes. You could also do that for
Right, you
batch
don't want us-
registration too.
Well, will they approve? You send them like a badge for people.
It will not approve that anymore, because, and that was on one of my slides, I think, DataCite requires some minimal level of metadata in order to register the IGSN. So you at least need, the person who registered and the sample type and, very few metadata. But DataCite has the ability to give you draft numbers, so you
Okay.
reserve them. And once the metadata are populated, they get registered and become certified. So you can do that actually with DOIs for your data set. You can pre-register, get a draft
Okay.
DOI which reserves
So
that.
that's the
DOI.
terminology, it's the draft
Yeah,
deal.
it's a draft DOI in the same way it's now a draft IGSN that you can take into the field and you register everything when you have the metadata.
Just to let you know, if you are pre-registering these draft or reserve IGSN or DataCite DOI IGSNs, please email me or the other curators, just so we are aware that these are pre-registrations. And that way we're not asking you for all the information, sending emails back and forth, just FYI. All right, so
And
moving.
this is the process in flux because the change at DataCite just happened a month ago. So we will hopefully, implement something that you don't have to write to SIGs anymore, but you click somewhere and say, these are draft IGSN.
This should be interesting with Bravo around.
Yes.
Because if you created the draft IGSN in advance, went into the field, and then you could use them directly in Bravo to pick the next one down the list in Bravo.
Yeah.
That would be awesome.
Yeah. I think it opens up actually
Yeah.
some really nice
Just, okay.
opportunities.
And then my next question is, what do we do with outliers?
Outliers?
Outliers in a data set.
Oh, that's your geochemistry?
Yeah, for geochemistry.
Okay, that'll be an earth chem thing.
Yeah.
This is just sample registration.
Yeah, no, we're talking about
Oh.
what would we submit, and it's a complicated data set, so to get an IGSN.
Okay, we can move on.
Okay, sounds good.
Sorry.
All right.
It's difficult with the dialogue.
It's fine, don't worry. So now moving on to the batch template. So I'm sure Kirsten has discussed this earlier today. So the Caesar templates, there are two kinds, the comprehensive and the simplified, and they exist and live in the Tephra community page in ECL. So each download will come with a README document that gives you an outline and information about the actual templates themselves. And it also comes with the Tephra, the Caesar quick guide down here. And that is going to be our vocabularies documentation with recommendations such as these are highly required fields, highly searchable fields. If you do use them, please consider using these list of terminologies. So that's something you could explore. So the simplified template has 4 different kinds. There's the core driver, individual, and site. Today, just for the sake of time, we're only going to do the individual sample simplified template. Moving on, right? Good? Okay. So, questions?
Just type in EarthChem Tephra, and you'll come up with the Tephra portal. And then it'll say sample templates, and then it'll go right down to exactly where she just was. That's just a quicker way. So when we develop these templates with Caesar, the simplified is basically the equivalent of everything that has an asterisk and was bolded and we think as a community is the most important, whereas comprehensive is everything.
It has a lot more information and options in there, not all of which will actually get archived in CSAR, but you can archive that Excel table with a data set and link it to a data set in EarthCam. So the full comprehensive background information could be made available there. And maybe someday some more of that could be
That's what,
injected into
what's
CSAR.
the other thing that is that CETA is changing the way metadata profiles are put together. And so I think that in the future, we can have the extended metadata profile for Tephra and everything gets stored.
But we figured with samples that people were most likely to put in kind of a minimum data set, and it's actually exceeds your minimum for CSAR. So it's still good.
CSAR had to have a fairly limited minimum just to be able to handle a lot of archives of stuff successfully, otherwise it just wouldn't go in.
Yeah.
What was that sample from 1875?
One of the first facilities that registered their samples was the Geological Museum of Harvard University. And there was 40,000 samples and not a single sample had a latitude longitude. So, you know, it was impossible to enforce geospatial metadata. The other thing is that we also register experiments, petrological experiments. So you don't have a lab long. So it's, you know, all these insights have come over time, and that's why we're changing the metadata now to make it way more flexible to, you know, actually enforce certain metadata maybe in the future for certain profiles, but also put together different types of profiles.
Okay, so we all have the individual sample simplified Excel file open. Yeah, whoever wants to.
All right. I would also suggest looking through the comprehensive when you have time, because it is a big template and it's important to just be able to understand and see where that is going from. All right. So this is what the data set that we'll be playing around with today is. It's from, they're actually samples that are real samples registered by Nicholas Letcher. I took his sample metadata and added into the individual simplified template. So
which file will be in simplified template that we need to open to get to this?
The individual.
No. So this is, I'm just, okay, yeah. So this is where it got confusing. So I actually added this data set in the agenda under the Caesar demo side section.
Oh,
Because this isn't going to live, this is not going to live in the ECL website, the Tephra community website. I didn't want to put it up there.
No, but I mean, like, let's say I open simplified template, I unzip it. So which file I want to open first? Which
Individual, the individual sample.
Individuals, that's kind of what's been trying to say. Yeah, thank you.
Yep.
you put the link into the chat, so we're having the same.
Can someone else do that? I don't think I could do that and share screen. I could probably share screen and let me see, chat. Let me see if I have it.
Oh, because you're sharing it, yeah.
I think this is the one. Can you just check to make sure this is the right link? That should be the right one.
Google Doc.
Oh,
Is it a Google Doc? It should be Excel. Sorry, maybe that's not the right one. Oops.
Good.
I never got back into them.
Here, let me just do that. It might be. Oh, that's the agenda. Sorry. Here. That is the agenda link. So here is the link down here. And let me put this in the chat.
I think that was an earlier graph
Okay,
there.
I'll move it for you.
Thank you very much.
So.
People dealing with this.
Should be in there.
Okay.
Okay, everyone should be in the draft that says final January 28th. So. click on that. so we have data.
Yes, okay. So I guess I could just look at it since we're here now. You can still see my screen? No, you can't, okay. Let me just do this guide then. So this is the actual data set that we're going to be using for our demo. And this is from Nicholas Letcher, who's actually registered these samples. I took the IGSNs out because we don't need them and we don't want them because you're going to use your own user code to register the samples. So if you go, you could scroll through all the fields and you could see that not all of them are filled in. And that's because as CSAR, while we require certain fields such as the object type and the sample name, which Kirsten has also mentioned about how, you know, like some are required fields, we do highly recommend the other metadata fields if you have the applicable information. Meaning, if you have a lat long for your samples, please consider including it in. While it's not required, and if you want to keep it a secret or keep it embargoed, that's fine, but at least put the locality of where you got the samples from. And if you have any more questions about that, you can always email me or email at info@geosamples.org, and I'd love to help you guys out and figuring out what information you guys want to put in, and that's necessary for you. So in this file, you could also see there's another tab, metadata mapping and definition. And this over here in the bottom is basically this. This is the I guess tab that explains to you what each of the fields are and what the required field is and the definitions, all of them, and an example. So I would really highly suggest maybe you guys take like a minute or two just looking at the file and looking through the different tabs to see what we included, what we didn't include, and what you might want to think about including when you actually register your samples.
So the reason for this whole mapping is that CSAR didn't have the fields that we wanted, so we had to compare the Tephra best practices with what already existed. And I think in the new CSAR, the new generation of CSAR, the hope is that they will build out a lot more fields that match ours. So right now it's kind of weird, but it's the best we can do. It's going to be the case with any existing database that doesn't have the capacity to change on a dime. But because of this work, it is inspiring you all to grow and change. And so anyway, that's what this mapping is all about. It'll help you to read the definitions if you're like, what is this? But if it's simplified, you shouldn't have to go to the mapping or definition tab at all. You should just go in and fill it all in. You know what? And to us, all of these should be starred. They should fill it all in. There isn't really a choice. If you don't have a lat long, pretty much use it. So I don't like that there's not a requirement there. All of these are required.
Noted. And each of the templates will come with this metadata mapping and definition. So when you explore the other templates, you'll see them there too.
But because this is machine readable, we don't have the definitions in here. So if you don't know what, for example, geological age is, just go to that second tab and, oh, okay, now I know what it is.
Right,
That's what that's
that broad that says Tephra best practice is equivalent to things that are in those spreadsheets in Zenodo with all the rest of the explanation. You can follow it back there. So
like, what is the data release? Well, to us, it means the date, the metadata will become public, and that's in there because it's also required by CSAR. Material type, and then it just maps to what their equivalent field. Now it's confusing.
Yeah. And there are some cases where we had two fields that then get merged into one on the CSAR side.
Okay, I think
All right, everyone's good?
everyone's good now, or otherwise scream.
I hear good news. All right, moving on. So now, if you go, so now we're actually ready because we have the data set, and that's the data set you're going to use to upload. We actually have the sample, we could go to sample registration and My Caesar. So I hope everyone has a tab still open in the My Caesar account. And if you go to register update samples, this is where you could do all the registrations except for web services, which is individual and batch. So the first one's going to be individual sample registration. The one in the middle, the third one, upload a new batch registration file, is the one that you're going to use to upload batches. Fortunately, you don't have to create a batch template because all the templates are already provided for you in the Tephra communities page in ECL. Did everyone find the tab? Okay. So I wasn't sure how this was going to go. So I prepared a short video. And so I guess we'll talk and we'll play it and I'll talk and explain some couple of things while we're going through it. Okay. I'm sorry if it goes a little fast. I didn't realize my clicking was really fast sometimes. All right. Register update samples. And we're going to register a new batch file, add a file. And this is the one I have on my desktop. So yours will be different, and upload. So here we actually see I didn't add the user code, and there's an error that says, please upload a corrected spreadsheet in order to register the batch in the bottom. The thing is, the Caesar batch process, when you're actually uploading a file, the system goes and does a first check validation, which means it checks for things like this. Did you actually include your user code? Did you include the object type? Is your lat and long in the right format? And this is a way for you and for the curators to know that you need to edit something on your file. And so what we're going to do is, because it's wrong, we're going to upload a new file. And what I'm going to do is I'm going to edit it, my file here, to include my user code, because that was the error. And I'm going to save this. It's important to note that Caesar at this current stage only accepts the Excel 94 to 2004.xls file format. Anything else would not be accepted. So we save it. And then we re-upload it. And you can see this time, there's nothing wrong and there's no error. You want to make sure you scroll through as best practice to make sure the information you actually entered is correct. You could still edit it using the batch update tool later on. However, you just want to make sure it's mostly done and perfect if you can. So once you're done, you could do register now, and you will be sent your submission was successful page. So from here, you don't have to do anything. Here, this is where I, as a Caesar curator, will get a notification email saying that someone registered a batch. I'm going to go and download the files, check to make sure everything looks right, and then register them for you and email you back the file with the IGSN number. And we could do this step, but sorry, another video, starting again. And so once that's all completed, just giving you FYI, you could actually search for your samples, in this case, Nick's sample. And if you click his, if you use the sample search, if you click his IGSN, you get the sample landing page. And this is what you would get as once your IGSNs are officially registered, which we will have with the DOI prefix now. So I wasn't sure what was happening with this, and we could see the video again if we need to. Are we dividing into groups, or are we just going to do individual, everyone does one?
I think people have followed this, so yeah. We kind of took care of that.
Okay. So how many people are in the room just who are registering?
There's a question.
Yes.
How long does that process take, upload until it's approved or sent back to you?
It takes within 24 hours. And if something happens, then 48 hours. So what happens during the process is, in this case, a batch is fine, so there's nothing wrong with it. If we find that you put the metadata that doesn't fit in the fields as well, does not the best fit, or something is missing, or your samples are all the same sample name. That happens a lot too. In that case, we would email you back the file asking you, can you please clarify? Can you please edit the file to make sure everything looks better? And then once that is done, we'll do the same process, meaning I will upload it for you and then register the sample. So depending on how quickly you also respond as a user, it could happen within a day or a couple of days.
Okay, perfect. Thank you very much.
What helps, just to add to that, what helps is if you want to generate your own IGSNs and you just register them, but you have them in use already, right? That's a way to, if you need something really fast.
But just make sure the IGSNs are all unique, because we do have instances where people repeat the same IGSN. And in that case, I can register the batch.
Is there a template for non-Tephra, like for just lava samples?
Yes.
I've just seen for the CSAR template. I mean, I know there's templates in the EarthChem system, but is that like for this batch upload for CSAR?
Well, you can make your own.
You make your own, you know, there is no predefined other one, as far as I know.
Can I ask a question now? It seems like a good time. So you use the Tephra template, you have some fields, right? Can you modify them later, add like extra fields?
You can, there's, yes, that's something we haven't mentioned, is the update function. So you can upload metadata later and add on to it. You can also go to individual profiles of a sample and, you know, make changes to that profile. But if you want sort of, you got your IGSNs with a minimum set of metadata, and now you have a lot more, you've been in the lab and just looked at what sample this really is, you can upload that as a batch as well, and it will add that.
So if you use the same IGSN number, it will match automatically.
Yeah, you can basically reuse that template that you had before.
Reason I'm asking, we have some old samples sitting there, right? So technically we would maybe want to make it more plain.
Yeah.
With the current understanding how it is.
And I hope that, you know, in the future, we can actually implement something that alerts users, since your profile is not very complete, right?
Like a score.
Yeah, I mean, we did so far, we haven't pointed that out, I think. On every sample landing page, you have these little icons that stand for this sample has geospatial information, this sample has classification information, and so on, which was the first step in that direction to encourage.
So like you could have, I'm halfway being facetious here, but you could have samples that get a sad face and a smiley face.
Right.
And who knows?
So I mean, this would all be, and I was just telling CSAI has very small development resources. It's, you know, usual limits in funding that make it difficult to implement everything that we would like to do. But right now, as we have this money from the Internet of Samples to rebuild things, a lot of these features that we wanted for a long time will hopefully be integrated, right? That it's just, it has been driving me crazy that we haven't been able to really respond to what turns out to be problems. So, you know, hopefully it will change.
Which means again that if there's something you want, please say so right away.
Please say so, put it in the gem board.
We actually had this in ISCORE community, what we came up with the standards. So we would develop like, you know, data quality standard one, for example. We discussed it, we never implemented it, but the idea was if your sample fields and metadata follow the standards, so the fields present, you basically get like automatic check for the system. And that's a really clean way of doing it, because then the computer system using it as a template, underlying template for data.
Yeah, this is out of ignorance, but we often have time series of samples. And can you refine that sort of time parameter in the templates or?
There is sampling time is
Okay,
there,
so-
yeah,
Because
sampling
something-
time is in, we have also time intervals,
Okay,
because one of the first types of sample that we actually implemented were dredges. So you had an on bottom time and an on bottom location and off bottom, so that is possible, yeah.
perfect.
What we should do is, I see still, a need for identifying groups of samples. So if you have time series samples, you actually want to make this a group where these samples are all connected in some way. And that's currently only, you have to squeeze it into this feature of creating groups. There is a function that you can create groups, which could be samples from a publication or samples.
Parent-child.
Well, it does say
No,
parent
this-
IGSN on there.
Yeah.
That was my question in terms of that, because there's a parent IGSN versus just an IGSN on this template. So like, would a parent be like the whole time series, the start of it, and then each individual one?
I don't think that would be good because it's more of a sample station. And so, it can vary quite a bit over time. So I would want to have their own current status, I think. But
Yeah, I mean, this discussion really emphasizes how complex it sometimes is. There are so many scenarios of, how samples are generated and how samples are treated that we continue to learn. We recently had interaction with the critical zone folks who actually use some sort of experiment to leach pore water out of soils. And so they wanted to make these pore waters experiments as sample type and so on. So you keep learning about the diversity, and we're just trying to keep up to some degree with that.
I think what was helpful, you explained to us the enforcement. So we can use different fees, the way we build to our data. And when you do that, you can keep in mind there is a community standard that best recommendations, but you can deviate from it. You're not going to be punished.
The punishment, so to say, is that discovery is less likely, right? Because the searches are kind of built based on the schema of the database. So if you search for certain terms in a given field, then it might not find your sample. Right?
No, I think what once your system will evolve, right, it will get smarter. But then
It will get smarter.
innovation.
I sure hope so. I sure hope.
It's just now, because now it's really level one. Level one.
If you guys want, I could show you really quickly. I didn't know how much time we have, so I cut it short. I apologize for that. But so if you do actually go to register update sample, and we see the register update individual sample, create a batch file template. Down here, update sample metadata. You could upload a file to update sample metadata. And this is going to be the same process as doing the batch. However, you need to make sure that your IGSNs actually match up. I don't have a file, unfortunately, on this user account, my user account here. However, you could do the same process. You could also, if you wanted, just go to, you could also, of course, add images and stuff if you want to, but under my samples here, you could also just edit your one sample if you like. So if you don't want, if sample number 2, IGSN IEZ000002 is fine. There's nothing that needs to be changed. You could do edit, and it will bring you to the sample edit page here. And here you could add, include information, take information that you need out. I'm sorry, this is very sparse, but here in field name, I could say a bomb or something. I'm just saying like a, let's see.
Bomb was good.
Volcanic bomb, yeah. So you could put that in, right? And once you're ready, you could also, you go all the way down, and you could do ready, submit to CSAR. And that's going to update your sample metadata profile page. So here, if you go down, let's see up here, field name, volcanic bomb. So you have the option to do individual edits too. I'm sorry, I don't have a group. I don't have a batch one. I didn't think that far, unfortunately.
That's okay.
Yeah.
That's okay. I wanted to mention one more thing. Can you go back to the My CSAR home?
Of course.
What we have to mention is a tab up there that's called transfer ownership.
Oh, you mean the actual, okay. My samples, you
Yeah.
mean, yes.
So it happens that people who have been collecting samples throughout their career, at the end of the career want to send the samples over to the Smithsonian or some other repository. So if the repository has an account in CSAR, all they need to do is go to transfer ownership, type in Smithsonian Institution, and all the metadata will be transferred to the curator of the Smithsonian. So no more, accessioning of sample collections that has, in some cases, I've seen the boxes sitting at the Smithsonian, that have been waiting for 5 years to be accessioned because there's no staff to type all the metadata into the Smithsonian sample management system. So this way it can just all be transferred. Or if that's happening within the USGS, let's say, you go from the ABO to
Well, we go
whatever,
to, yeah, we go to the
repository in
GM.
Golden,
Yeah, we have an Alaska repository, but I don't know that
We
we
retain the,
do it like this.
you retain the stuff.
but presumably the Smithsonian could say they wanted one of our samples and we would have to give it to them and then
Yeah.
Then
we have
we
an
would transfer
agreement,
it, yeah.
But it's not as simple as what you're saying. This would actually be smart for Cheryl to do.
Just to
Otherwise she-
clarify, you have to include the ORCID of the recipient, not just look up Smithsonian. So whoever the person you're sending it to. So if I'm sending my samples, to I gotta put an ORCID
it
in.
does have to, it can't be an organization.
Well,
This is another change that will be coming is that we will better define and equip institutional accounts, because with the change to ORCID, suddenly we realized, that this is now difficult to set up an institutional account because you don't have an ORCID for the institution. You need the ORCID of the curator, right? And so that's another change that will come, that if you are a repository, you have a different type of account.
So it's-
I also do want to point out, since we're here. Oh, question?
Can you talk about images, like how many you can put them, like just a little bit more?
Yes, so if you go to, I'm gonna go to individual sample. Well, you could do here too. So there's two options. There's under register update samples, you have upload files, images associated with samples. So this is important. This is where you could do multiple images for one sample or multiple images for 3 or 4 samples. So you could do add file, and let's see. Please don't look at my browser stuff. It's very messy sometimes. Let's see, CSAR. So let's see, that's not it. That's a good one. So this is a TIFF file. And the thing is that we can't accept file images that are over 10 megabytes. The JPEG that's over, 4 megabytes. JPEG images that are up to 10 megabytes will automatically be recompressed, compressed into the right file format. And you could do PDFs, you could do TIFF images, you could do PNGs, whatever you prefer. And this is going to be, so I'm going to look up IAVCEI. I believe that's my one. And then Oh, why did I? Sorry, give me 1 second. I gotta go back to my samples and see my actual. Right, because I forgot the code. Sorry, I'm using the old system still. And so we cancel
So
that.
why do you have two IGSN for one image?
You could, I mean, depends. What if it's the same image? You don't have to. I'm just showing you that you could. So you could upload it that way. And so these two IGSNs will have the same image. Certain times what happens with that, if you have a sample, maybe you have two samples that are taking the same image of, and one's A, one's B, or they're siblings of each other. You might want to include both, the picture of both of them, so that you have a reference.
What often happened is that people attach photos of the field site where they collected it, and then you have multiple samples that you want to link to the same image of your outcrop. And that's.
So it's not really a sample, it's a field site.
You can select what you want to put there. You can also, I mean, the profile also accommodates PDFs or any other files. So if you want to upload digitized field notes or some historic field notes, so you can do that as well. Doesn't happen very often, but that's something to with Strabo stock we obviously need to consider.
Right, I have archival stuff that I've been putting in scanned pages of field notes as images and probably next to pictures. At least they're available somehow.
But not everybody's using Strabo, so we, that's, I mean, this system is a lot older than Strabo and was meant to.
Is there a way to batch this? If you have 20 samples and 20 images.
Yes, as far as I remember, that was built, but I have never myself used it.
What was the question?
It was about batch uploading of images, that you have a whole batch of IGSNs to which you want to upload samples. I know that Lulin developed that.
So do you mean like different sample images or like the same images?
Yes, different images for different samples.
So in that case, you can't actually upload like a batch file with images associated with it. Are you?
Weird.
Yeah, because the only way you could do it is by going and doing it here, and then adding the files, and so whatever the image is, then you enter the IGSN that you wanted to include it in, and then you add another one, add another one. I've never actually heard about being able to do it on a batch. However, you could put related URLs on the actual batch as long as they're the same related URL type per batch update. Does it make sense?
I mean, the challenge is with a batch upload of images that you need to have unique names for the files, right?
Right, and you need to know which file goes with which
goes with which IGSN. So you not only upload images, but you need some file, spreadsheet or whatever that maps the file names to the IGSN.
We have a template, well, in the comprehensive sets of data, a template for describing image metadata that would have a file name, and what sample it went with, and those that could have IGSNs in it.
And this says it's limited to 3 files per IGSN, right? So this is not, I mean, I don't blame you. This is a huge infrastructure to actually do an image. You're not really an image database. You have an option for some stuff, but like if the microprobe community wanted a way to have a database of backscatter electron images, this is not it yet. That's something we need to build. So
in that context, so EarthChem got to have a sister project in the last few years called the Astromaterials Data System. This is basically the same as EarthChem, but for samples that NASA curates. So I'm getting funding now from NASA for operating this Astromaterials Data System. And we're currently building that up to accommodate all the analytical data and imagery that's going to be generated from the OSIRIS-REx project. I'm not sure you know about that. That was a spacecraft that is on its way back from asteroid Bennu and collected samples there. And so in September of this year, they're going to be starting to analyze these samples, take lots of images, CT scans, and so on. Have to archive all imagery. So we're going to learn now how to deal with imagery in a big way. And right, I mean, NASA is going to pay us for the infrastructure to host all that. We're actually getting cloud storage space with NASA. For EarthChem and CISA, I don't have that yet. But if that, this is becoming a big concern because so much of the geochemical analytical data now is related to imagery, to backscatter images, to stuff, and strobomicro is a sign for that. We will have to have the infrastructure to archive that. And I'm actually running a workshop this summer at the Goldschmidt conference, in case you're there, on imagery and geochemistry and how to archive that properly and link, sorry.
Can I just, add a comment to that, because it's not only geochemistry, we have like lots of imagery for physical volcanology as well. That's really important to what we're doing.
Yeah.
So if you're already starting to think about implementing changes, it would be great if that side of things could be part of the process, because we don't really have any place to put it currently.
That's part of this building, this future generation Tephra based system, right? So in the gem board,
Oh, absolutely. Yeah.
Yeah, because I think it's a bad idea to link existing systems. It's not going to help you with the future.
Similarly, we have,
Like if you just, it's an EarthChem, right? So you can't put physical.
I mean, currently you can put like sieve data or componentry data from the lab into a repository, but it's just a file.
Yeah.
Right. There's not an integrated. We don't have a EarthChem synthesis library for physical volcanology where it's all in one data system and you can just query and sort through everything.
Well, what I envision is that geoscience sample nexus that I talked about, that could actually link then the samples to other files. It's, the chemistry will all go into the synthesis because that makes sense, right? There is some physical properties that we have actually through this EarthDeep project. We have been ingesting physical properties of Tephra already. So that is part, it's not yet accessible through the search interface because obviously you need to make changes to the search interface. But that, it's something that we can consider. And that is why we're having this discussion, right? So we actually know this.
That's why I want to mention it. I know that things have to live probably in different databases, but with sample database, as there are capabilities to link to things, just
I think that it's a good question for you is like, is EarthChem going to be, is its mission always going to be chem only? Because the physical community has a need. It's often one-to-one related to a chemical sample.
To us, in this new brand that I mentioned, the IAVCEI next generation data infrastructure is focused on sample data. It's all, there are facilities that do time series data and geospatial data. We are specialized on sample data. And so I want to, this sample nexus is something that sits at the IAVCEI level and not at the EarthChem level. It's the part that has the lab analytical data, and other information that pertains like the metadata and so on would link up to a common central discovery place.
Can you also
And external systems can participate in that.
coming back to images, can you take archive file like zip file for IGSM and Then you have a bunch of images to your point.
I think so.
Because physically, why not? You can store it.
I mean, there are two aspects to that. One is to just document the sample, right? So it's somehow accessible, the images. But are there also, needs for searching through the whole image catalog or database, right? What metadata do you need about the actual images?
Right, so I have,
And that makes it way more complicated if you want to.
I have one small batch. It's only 3 samples, that went in last year. So there's geochemistry and there are some images, and I filled out our image template. And so there is a spreadsheet that has the file names and it has like the information about the scale of the image and what sample it was collected on and what machine instrument was used to collect the image. So it has some of that image metadata in it with the file names, and then there's a zip file full of those files. And that's sitting archived at EarthChem now, but it's not in a format that we're set up to be able to search.
To be searchable, right?
You could
exactly.
discover that it exists because you could find those back to sample to the geochemistry and then realize that there are these associated files with that record, but that's as far as it goes so far.
I feel like because AVO has a really nice image database. We always struggle because it's not every image everybody takes. Because the work that goes into making it useful searchable images, you have to enter all the metadata, capture and all this stuff. There's no way to purely automate that. When you could enter the exit data from your camera, but that's not what we want. We want more of a description. And so I think we rely on the idea that every geologist uploads representative images from their project with the metadata. And that's a lot of work. And then you have an archive where you store all the files. But I mean, the other thing is images are huge, right? Like I was just thinking like.
That is the problem. I mean,
120.
we have calculated for this Astro Materials data system that we're gonna be in the petabyte range.
Oh yeah, one modern camera, consumer SLR camera image is like 240,000 chemical analyses with 100 pieces of data and metadata. like that's one photo. So the storage is like totally different.
Yeah.
Can I just? So sometimes we have videos of samples that we're
Go ahead.
5,000.
saying.
I remember there was a big issue for this sediment experimentalists network that existed at the beginning of EarthCube. I remember they had all these videos of experiments in morphology, geomorphology, landslides and whatever. And it was their biggest challenge was just the sheer size of these files.
Right, the CBO and the Lahar.
Well, or a lot of the sampling.
Sampling is.
I mean, I think there's a whole different sort of template that needs to be developed for eruptions. So like that
Wow,
conversation,
yeah.
Converse, the time series, all those things, it's a different suite and we have a different suite for ours. It's additional information. It's, we strip it out of our day-to-day because it's not necessary, but that's what you're looking for. Yeah.
We're looking for a place to get things out
Yeah,
fast,
Yeah,
basically.
yeah.
And help the research community to actually, make sensible requests, because we get a lot of.
And we can learn from I know that, there are fantastic archives such as Mbari, the Monterey Bay Aquarium. They have a whole archive of videos that were taken by submersibles, of creatures underwater and so on. And they have organized it in a good way. So, it would be nice to actually get in touch and say, what did it take? And how much space do you need? What's the level of resources to do this? But it's daunting. It's daunting.
Also, today you can use Zenodo. They have a limited storage.
That's true.
Well, yeah,
The
I mean,
Nodo
we
is-
can by just having a URL in the sample description and then host the videos ourselves.
I mean, that's what we have for like, that's a science base is good for.
I think we should release for,
Yeah.
for saints, where it's getting really late.
Yeah, take a break.
Saves, thank you.
Yes, thank you so
Yeah,
much.
no worries. I'll stop sharing first of all. Stop share. I will actually, we do have how to basically upload using the batch update tool. So if you like, I could add that to the Tephra agenda, just so you guys have it. So you guys could refer to it when you need to. And we did have one person who did submit and have gotten a sample registration, pretend sample registration batch back. So congrats to the person who's gotten it. I can't remember the name. Someone in the room. It's Nels Iverson. Yeah.
Don't
So-
worry, I have more questions.
So everyone have a good night. Have fun.
Can you put the link in the Jamboard instead? Do you have
Where's
that?
the Jamboard link?
So at the top of the agenda, I'm worried about you're in a different agenda, but at the top of either one.
It was an audio one that I had.
Yeah, I got an email. That's.
You should see a link to Jamboard. I can put it in the chat.
Yeah, if you put it in the chat, I'll definitely put it up there. I'll put the presentation up there too, so you have a reference to it.
Okay, there's the Jamboard in the chat. It's posted on page.
Yes,
Don't tell me.
We can also post video on our website, link the videos.
There's actually too many voices. I can't really hear anybody clearly.
Yeah, if you could just paste that, when somebody you're talking about on page 5 of the Jamboard.
Where did you put the link up yet? I don't see it yet.
In the chat, it's in the chat of the.
I don't see any Jamboard link on the chat.
Oh, I see, it's going to. Me,
Anything in the chat that was before we joined. Not be visible to her.
Sorry.
I'll put everything up there. I'll put the presentation too, just in case anybody needs reference to it, okay?
Now, yeah. Thank you.
You're welcome. Thank you guys. Have a good rest of the conference meeting workshop.
Christy, we're doing tea,
Time.
so people online can come back in 10 minutes.
Yeah, let's say virtual folks, 10-minute break.
Imagery data.
Semi.
Miles might say, one image.
Showing the stuff.
It's bigger than the
Started out
entire.
with it. I didn't, some I got it so like. Actually, what was she saying?
Oh.
Is that, but so like when you're doing hands-on, if it's the guided hands-on, it's just, you can just look through really.
Okay.
So you're not, people can try to follow, but you're not actually.
You know,
They don't have to.
that's the goal.
I know it's kind of 3 separate processes. Chance to like. All right, I'll talk to them.
That's you go search. That's nice. It's not good. Then we have internally. This is such a trend. Yeah. Yeah, try to.
Storage is getting cheaper. Like, who wants how much it costs, and it's gonna get cheaper. So I think we shouldn't worry about it.
But part of it is the linking metadata, so it's like you can't back upload BSC images and add all the exact same, yeah, it's, that takes a lot. But
I think archive files, because it's simple, they can pick up the same file and achieve see, like, see the
We can use that, I guess, yeah.
There. Yeah, it's not easy.
Things we could.
Each year response.
Screens. It depends on how it's at, it depends on whether it's, APO does data. So. Alaska, so the like stuff is just do it. But the number of do it. You know, and then they go great. There's a lot of things. It's almost frustrating.
We're adding layered. Strats.
We have actually put it in your. Well, but actually, the one wasn't, so we work together.
So. Stats.
Science. It's great.
Sample.
Geospatial. It's just it's very low distress. It's really at least at that level, there's a that's recognizing inside space data great. Yeah, it's the ABO has a separate database for every other site. Everything else is that's the thing, it's like GeoRock. Getting data. But it's easy to use for ourselves.
Yes.
It's there.
I think it's only. Well, then this is both itself. There's such a
These just more interesting. It such should be. There's.
That's right. Image database. Sample database. Reference database. They all link to each other. You know, one.
Yeah. That's really GeoRock.
Well, I mean,
It's the idea that. And it should have a database.
You're only. Two.
Very exciting.
That's where I think.
Make your database ready, database, open database.
that was very helpful. Cesar.
Realizing like all of
I
this.
think it was a
I mean,
really
I
good.
hope my memory will work. But this is like finally.
It's, but it's always mind-boggling to me that you just do in these situations, it's like, oh, what are we gonna do here?
It's like, you know, from the sense of, what's a big deal? Like, very. It can. It shouldn't be. Yeah, it's a better. I see that. They want to take.
I mean, we had. This non-color chart. I mean, we've worked so much with this
I mean, it's pretty, yeah, we'll have to just talk.
We're going to get started up again here in just a moment.
I mean, I can sit there.
Next one on the agenda, we're going to be back to
I have
Strabo.
point in that. Yeah. Yeah. She's gonna do. I can, let me.
It's my struggle micro's not installing. It like goes through the installer, but then it just like once I have it on it, it's Java based, right? I suspect we have a lot of Java, so I suspect this may be a problem. So, yeah,
I will,
it installs, so I didn't older version, it's just nothing happened.
okay, it's like probably getting close to like 10 PM there.
Yeah.
Go ahead and take it first. We're gonna, yeah, but I'll definitely make note of that. That's odd. It's odd that there's so many people running into.
Oh, other people are not, it's just not explained.
Someone earlier in the day said that they were running into an issue with
Yeah,
it.
typically, yes, and it's just.
Let's move around. Two things.
I just checked. And I'm sure we can go downstairs.
I'm gonna say there's a lot of not happening.
Okay, ready?
Yeah.
Okay, all right, we're gonna start again. Is the. Okay. So we're doing sort of what we call a guided hands-on, so it's not as detailed as everyone having to do everything, because that was for Strabo supposed to be tomorrow. So this is more just sort of like more than the introduction which you gave earlier, right?
Yeah.
Yeah.
This is a little bit more along the lines of, it's built in a way that once we go through this, you should have been ready to kind of go into the field with your iPads and stuff. So some of the stuff might be a little bit introductory, but we'll just breeze through that part and get to the exciting stuff towards the end. So yeah, kind of the goal this afternoon was just getting understanding, going through a pre-field workflow and practice adding data. I guess I can point out though, if anyone has any questions while we're working through this, even if you're not working through it, feel free to stop at any time and I can pull up the app or something and make things a little clearer. So yeah, once you download the app, it's very straightforward. You just log in with your StravaSpot username. You start a new project, and then you'll kind of follow through these separate windows. Again, it's very user-proof. You just hit buttons and it takes you to the next window. But once you hit Save New Project, you're going to come to this Active Project window. Here you have a few options as to what to do, but what I would recommend doing is clicking up here on the active project. That is going to bring up the project description window. And here is where you can fill out all of your project metadata. And so I think the sentiment kind of in the room and through Strabo is just fill out as much data as possible. It's so much easier to fill it out beforehand. And this is just a note for going into the field. The magnetic declination of Rotorua is 21.7 degrees east, but it is worth noting you don't actually have to put that into Strabo. The magnetic declination is automatically accounted for in the iOS compass. So you don't have to do that, but it is good to have that written down somewhere when you're looking back at your notes. Another thing to do before starting your actual project in the field is to edit data sets. So if you click on this pencil over here, you're able to change the names of your data sets or add other data sets. So there's a little bit of freedom with what you want to do with the data set. If it's a pretty small project, you may just have one data set. But a few ideas for using the data sets is one data set per field season. So I know people who do it for 23, 21, 20, one data set per subset area. So if you have like a northern area and a southern area and want to keep those data points separate, data sets for different features. This is something I do quite a lot in my workflow. So I will kind of keep my contacts in one data set, my faults in one data set, and my point spots in one data set. This is a little bit more involved because it makes me just have to switch around data sets a little bit more. But I tend to be working with really big data sets, like 700 spots. And sometimes you just want to look at the map with the contacts and without all of that jazz. Another thing you can do with data sets is group work. So right now, there's not really an efficient way to do group work if you're in the field and all want to be adding data to the same project. But the one workaround we have for that is you all take your iPad, you all log on to the same account, all on the same project, and then you have separate data sets. So what that does is it's going to look like a bunch of separate data sets on your iPad, but once you upload that to the Strabo server, they're all going to be separate data sets within the project. And as long as you're making sure you're working in your respective data sets, you won't overwrite each other's. And I've used that a few times and know a few other people that do that for larger group work. And right now it's a pretty okay workaround. I think the hardest part of that is you're all logging into the same account on that. So now just navigating the app. So with Strabo 2, map is kind of your base. So it's a little bit small there, but basically you have, I'll just point out some of the key features. In the lower left-hand corner, you have your location button. So the location is not always kept on while you're walking around the field. Otherwise, your battery would drain pretty quickly. So if you want to update your location, you just have to hit this. These three icons on the left here have to do with map actions, map symbols, map layers. We'll get a little bit into that later, but it's basically what you're going to do to interact with the map. Over in this corner here, we have different ways to add data and spots to the map. And then up here are two important buttons. This is our home button, which opens up the settings and preference menu. And then over here, we have the notebook button, which opens up your notebook where you can add data. So over here, we have the settings. We'll kind of go through these in a little bit of a different order. But to get to settings, you simply click the home button. It's all right there. Over here, we have the notebook. You will notice if you just open the notebook without having added any data, there's going to be no spots in there, but you can add a quick spot to the map. And then you have a blank notebook right here. So with the notebook open, you can see we have a few pages down here. These are pretty common pages that people are going to be using: geologic units, notes, measurements, photos, that like. But if you want to see more pages, we're going to have to click more. And then that brings up all of these pages that you can toggle on or off depending on what your workflow is. So then we did have one special step for Strabo Spot, this Tephra workshop. Basically, this comes down to the fact that Strabo Spot SED and Strat functionality is it's basically ready to deploy to the public, but we still have it in testing mode. Basically, we're having meetings before this workshop to decide whether or not to release it to the public or to have you all be in testing mode. We decided to go the testing mode route because then we have a bunch of lovely testers in the field. So if you're looking to do this, and I would recommend if you're playing around to try this, because this is how you're actually going to be able to see the stratigraphic column and add that to your app. All you got to do is go to our super secret preferences, go to miscellaneous testing mode, and then put in our super strong password of Strava Rocks. So once you do that, next time you go back to the more pages, you can open that up and then you'll see all of the said features down here, including your strat sections, intervals, lithologies, and all that like. But once that's made publicly available, you won't have to go through testing mode unless you're actually working with us as a tester. So before going into the field, here's just a few things kind of in my workflow that I think are, you don't necessarily have to do them before going into the field, but they will make your life a lot easier if you do them while sitting in the shade and not out in the sun. Except downloading maps, you do need to do that while you have service still. So we've already started a project. We've already changed our data sets. Also make sure to charge your device before you go into the field. This is very important. Also, I know I'm out here speaking Stravo, but also just bring backup maps and all that. Like, it's not a replacement for that sort of things when you're in the woods. Okay, so naming conventions, which again is under preferences. This is how you can change names are going to populate each spot you make. It's good to know where this is, just because if you make a mistake and delete a spot, it's usually nice to go back and fix where you're at in that spot lineup. This is also where you can add prefix labels and starting sample numbers. And if you are working with like the IGSN method, you can just put your 3-letter code in the prefix label and then start your sample number at whatever number you're at, but I'm not sure exactly how that would work if you have to have the like reserved samples beforehand. So then the next thing that's pretty critical to do before going into the field is downloading maps. So unless you're working in an area where you have service or a hotspot, you're going to want to download some maps. To do that, you basically just zoom out to whatever area you want covered. You select what type of map you want downloaded. So typically your topo map or your satellite map. Then you navigate to these 3 buttons here, hit save map for offline use, select the number of tiles you want downloaded, and then just wait for it to download. A few points with this, typically when I'm doing this, my workflow is I kind of choose a spot, download it in topo, wait for the tiles to download, then just change it to satellite so I know everything's covered. I would also not recommend zooming out to like a super huge area and trying to download just like tens of thousands of tiles. It's usually goes a little bit better if you just kind of chunk it up depending on how big your field area is. Another thing you can do is download custom maps or add custom maps to work on. So I didn't get very much into this in the slides, but I can show you how to do that later if anyone's interested. There's 2 main ways to add custom maps, either through Stravo Spot My Maps, where you can upload TIFFs from like ArcGIS. I use this to like upload my LiDAR maps. You can also do different types of map styles. And then once you load your custom maps into Stravo, you can also download these for use in the field. And then once you're in the field, you're able to toggle between all of your downloaded ones. So like it's very common to toggle between your LiDAR, topo, and satellite all while in the field. So another thing that's really useful to do before going out into the field, especially depending on how many units you're going to be dealing with, is just creating your geologic units beforehand. This is also good because it gives you a little refresher in what units you're actually going to be looking at. So to do that, you go to settings, attributes, geologic units, and then it's create new tag. And then in there you have this field where you're able to populate it with the information that's relevant to your geologic unit. So here you'll see all the geologic units we could have seen had we been going out, and you would have been able to populate. But for now, you can just kind of look at them. So now that's kind of covers all the things I think are pretty important to do before going into the field. It seems like we're ready to just look at how you actually go about adding spots and adding data. So to add spots, it's pretty straightforward, but you do have a few options, and they all come down to these icons down. So you can either add a point, a line spot, or add a polygon spot. And then we do, this is actually kind of a secret feature. If you hold down on the icons while you're in the app for like a long hold of 3 seconds, it toggles between the different types of points and lines. So for example, with these ones, this just adds a point to wherever you press on the map. But with this guy, it adds a point to wherever your location is. You can also toggle between these more vertice-based lines and polygons to a more free form drawn like line or polygon. And so some of these are just personal preference as to what you like to use while in the field. So inevitably, you're gonna have to delete spots. And so in order to do that, once you have a spot that you want gone, you open up the notebook, tap on these 3 dots up here, and then hit delete spot. Then that spot is removed. If you want to edit spots, so you want to move them around or edit just like a vertice of a line, all you need to do is find the spot you want, hold down on it for 3 seconds until it turns orange. It's now movable. So then you can drag it to wherever you want on the map, hit save edits, and then the coordinates will update to wherever it is. If you're working on a line and you want to add some more vertices or delete some vertices, you can do that by either pressing down in the center of a line or by holding down on a vertice that's between 2 other ones. So now that we have some spots actually on our map, we can go about adding data. Adding data is all going to be done through your notebook over here. So you can navigate between these different pages. I won't be going through all of these. A lot of them are pretty self-explanatory, but a lot of them do have these quick entry modals. So when you hit the compass, it pulls up this quick entry modal, which then allows you to populate these forms as needed. A few things to note here. One, throughout the app, we do have this option to use templates, and that's pretty convenient if you're doing, so for example, I take a lot of measurements of like solid state foliation. So I might make a template that is for my solid state foliation. And then every time I create a new spot and go to measure it, these fields are automatically going to be populated with that information. Another thing to note is when using the compass in the iPad, there's so when you're using, I'm not sure how familiar you are with the app or if any of you have used it, but you can use your actual iPad to take measurements. So if you have a piece of bedding right here, you can just lie the iPad on it, tap, and that takes your measurement. The things to remember with this is that if you're taking a planar measurement, your iPad is the plane. If you're taking a linear measurement, the long side of your iPad is the line. And then that means if you're taking a planar and linear measurement together, say you have a rock that's like this, and you have like some slicken lines like this, you put your iPad on the face, and then you align the lineations there, click, and then your measurement saved. So it's pretty straightforward, but sometimes it can get a little bit confusing when you're first starting out to remember how am I orienting this. But again, you can always double check with your Brunton and vice versa. So one thing to also note is once you take these measurements, if you have it popped as bedding or foliation, you're going to be able to see these symbols on the map. You can toggle those on or off using the star icon. That's basically if you don't want to see certain features, or you can also turn on and off geologic unit tag colors. So now we'll move on to adding samples, and this is starting to get a little bit more into some of the Tephra vocabulary and Tephra workflow. So we have a spot and we go to add a sample simply by hitting this little hammer here. We can fill out some basic data with it. And then once we hit save sample, it puts that in the notebook. So now there's a few extra steps to actually add some Tephra best practice data. What you're going to have to do is click on the sample, which brings you to this other field. Go to main sampling purposes, and then you can select your main sampling purpose, and you can select things such as an active eruption. And here you're going to get a much more intensive sample field where you can fill out all sorts of data. I mean, here you got source spent, you got main sampling purpose, sampling surface, just things that are a little bit more in depth than simply, is this sample in place? Is this sample oriented? Another thing you can add to a spot are images. Straightforward, you hit take an image, you take your image. You can also sketch right on top of images. That's a free form sketch for drawing any annotation you'd like. On the images though, you can also turn on these image-based maps. And as discussed earlier, these image-based maps allow you to directly add spots or polygons to these local coordinates. So now moving into some of the Tephra data forms, we're just gonna walk through these pretty quickly. I'll be able to share these slides if you want to get some more in-depth look at what some of these fields are. But first we have lithology. So again, some of these you're going to have to navigate to volcanoclastic. You're going to have to turn on that field before you see the rest of these fields. So in here we have texture. You can add your class sizes, sorting, class shapes. Here we have composition, where you can say if it's discrete, disseminated. We can add our bedding, bedding geometry, talk about our contacts, our upper and lower contacts. We can add set structures, processes. I will note that all of these, you can add them either to a spot, so as you have in the field, or once you begin to build strat columns, you can add them to different intervals like along that strat column. So to add a strat column, you simply choose the spot that you'd like it to be at, or create a new spot where you'd like it to be at. Navigate to the stratigraphic section page, and then click add a stratigraphic section at this spot. That brings up these windows, which you're able to populate with all the data you need for your stratigraphic section. A couple things that might be worth turning on, especially for the Tephra workflow, are showing the labels for miscellaneous lithologies, because otherwise, if you populate some of these fields as like a volcanic, that label just isn't going to show up on the x-axis. One interesting thing you can do with the strat section is add an image overlay. So if you have an image of your stratigraphic column that you're going to be measuring, you can take a photo of that and add that behind your strat column. And so then as you're adding these different intervals, if you took the image at the right angle and got it in there well, these should line up pretty well. But in order to actually view the stratigraphic section, you simply hit view stratigraphic section. That brings you to this kind of blank stratigraphic section. And from there, you're able to add intervals using this add interval button here on the right. And that brings up the interval form. And then that adds your intervals to them. And so now you have all of the stratigraphic intervals, and you can add data to them just as you would add data to spots. So if you want an image that's for this entire interval, you just go to the image page and add an image. If you want notes for just one specific one, you can add notes to just that. Or if you want to be more specific within the strat column, you can add points directly to places within the strat column. So if you want to say that you took a sample from exactly this spot, this high up within the strat column, you can add a point right there and then add a sample just to that point and not to that entire interval. So now that you have added some data, added some intervals, added some spots, one thing to note is you can either view them by searching around your map, or you can go back into settings and preferences. And here we have a few just quick accesses to data under our attributes. So here we have a spot list, an image gallery, and then a sample list. So sometimes that can be pretty quick if you're looking for like a very specific image that you know is at this one outcrop, or you're looking for a very specific sample, and then you can view that in Spot. So once you have all your data, it's really good practice to back up your project to your device or upload it to your Strabo account. A few things to note with this: just back up your project a lot, like more than you think you need to. There's nothing worse than like getting like the black screen of death when you realize, oh shoot, I have not backed my data up in a while. If you're really bad at this, I actually know some people that just set alarms on their phone to go off throughout the day. You might not have to be that extreme, but it's definitely good practice, at least at the end of the day, to back up your data. And then these backups are all local to your iPad. And there's a few things you can do with that. So for example, if you're working with some other people and you're unsure about having it on one iPad, you can airdrop projects between different iPads just so they're saved in a couple different places. But then once you do have Wi-Fi or service, you're able to upload these projects to Strabo Spot. One thing to note is when you're uploading projects to Strabo Spot, it's only going to upload the data sets that you have actively turned on. And you can do some things with this to overwrite data sets you want to, but then leave other data sets that you don't. But when you're backing up projects to your device, it exports all data sets, whether or not they're on or off. But you'll see if you look on your device, every backup you do is being saved as a separate like .json. So yeah, that's the short and sweet overview of the Strabo Fields app. That might have been kind of quick. So if anyone has any questions, I can definitely pull up the actual app and show you, or yeah.
It doesn't seem likely that we're going to do the field trip tomorrow, but I'll read you what David wrote so we can make a decision. Of course, he's at the field site. And let's see, forecast is good. Basically, what he's thinking is, like right this second, he said it's raining so hard, like I would not use any digital tools in the field. And so, you know, I brought a pile of plastic bags. He's trying to figure it out. But basically, he said currently steady rain, would not use any laptops. Maybe best option could be to see how the morning looks. So still arrive here at 8. And if it looks like there might be a small break, maybe just so we can get a breather, we could drive to the site, get to see it, a little adventure, and then go to, I mean, it's all networking time, right? Then go to the Redwoods and have our lunch, because we have those packed for us, and at least like get out of here a little bit and hang out. Or come at 8. If it doesn't look good, we'll continue with the workshop and presentations and such. And then if there's a break between beginning of the morning and before 1, we could do the same thing, like all go to lunch together, stop and see the site. Whether we could get out or not is to be determined. But what do you guys think? I told them I would gauge the group. I don't think that we'll be able to do a full Strabo stitch, but
like CDR.
Yeah, I mean,
Could have won.
that's a bonus, right? We wouldn't be
I could have won
disappointed if we
cover of that. Can't really
Bands
click on
and
it.
that's, yeah. I feel like that wouldn't be disappointing, but,
Guarantee that we all at least got to see Tephra in person once in New Zealand.
it's 10-minute drive from here, so anyone who does have a vehicle on a nicer day could actually go there and hang out and see something interesting, so, other thoughts? Matt, oh, you're. Yeah, so why don't I let him know that, we can do the option where we show up at 8, looks great, we'll be ready to go. If it doesn't, we'll continue with the workshop, but be looking for those windows, especially, around lunch or maybe 11, and still be able to see it, have lunch together in the Redwood Forest, and then just come back. They did spend a lot of time, I'm sure, putting together that field guide, which you have now. He has hard copies and he'll bring those regardless. So again, another tool you could take with you on your own on a nicer day, hopefully over the next week. In terms of practicing with Strabo, I guess we'll talk tonight or during the social hour or whatever to come up with maybe a creative way of trying to provide more of a hands-on experience. So if any of you guys have thoughts or ideas, if you want more one-on-one or just, to get started, like this is the time to try to figure that out. It's not ideal, but I mean, you could Strabo swap the side of the hotel or I don't know, it's kind of the same thing.
Right, and there is, it's not the same, but if you're logged in to the Strabo website, you can basically do most of the things that you can do in the field app and on the web. Obviously, you can't stick the computer onto the thing and make sure it's right in depth, but you could add pictures, notes, samples, just sitting here on a laptop, play around with something. And it's the older interface still, but that's how I have an undergrad student putting in archival stuff. And it actually works pretty well. At least get some more familiarity with it.
Okay, so that's what I'm gonna write him back. Does that seem okay?
Yeah.
Aim for that, yeah, so still come prepared to decide to go and it dumps. You can get out of the vans or not, but at least we'll.
Christie, forecast is really bad. I think what we could try, Thursday is gonna be the first day with breaks, maybe we can gather like some afternoon, Thursday.
I mean, I can ask these guys, I'm sure they're super committed.
Maybe not even driving,
Oh.
just simply we can meet somewhere. Thursday, we can email, like just keep in mind, like some Thursday afternoon that we can try some. Let's try.
How do you get there? I mean, people have vehicles or what do you, I'm not sure what you're suggesting.
We
The
first we'll just book the time, Thursday, so we all like don't commit any like after lunch. Thursday.
It's the town hall.
Yeah,
Yes.
Yeah, unless you have a meeting. But that's only day when it's gonna be like better weather.
it's up to you guys. I have
Tomorrow
lunch.
is like, you look at the forecast, it's like,
I mean, it does say in the morning, it's supposed to be less than 1 millimeter per hour.
That's pretty good.
Which is right now, it's somewhere between 4 and 7 millimeters. So,
A millimeter an hour.
We're hardy. Well,
good, yeah.
Okay.
So just be ready.
I think just be ready. And we have plenty to fill in the time with if we end up hanging out for a while. And if we do go out, it would be short-lived. It would be a quick visit to the site, have our lunch together, come back here and then we'll think maybe a little bit
What
more.
if we should something like look at the state files that work?
Sure.
That might be.
Yeah, I mean, we can look at a lot of the stuff that's on the website too.
Yeah.
Is in Strabo 1, there was like a CSV export in the field. Is that
You could do that on the website.
well, if you don't have the web, I'm curious, because like that was something we really relied on, was the ability to get our data into a spreadsheet basically in the evenings when we don't have internet. And I'm wondering if that's an option in the new one, or I think the other option is just like, if the plugins for QGIS work, can we just directly get the data out, I guess, yeah.
Yeah, so the workaround to that is basically, so there's, I can share the stuff on the screen.
But if you have a Travel One device, I can just download the same project.
Oh, interesting, you could record it, yeah,
Well,
but yeah, long term though, I mean, yeah.
but so there's Rick Allmendinger's StereoNet.
Yeah.
If you want to get to that, you can basically lasso spots for StereoNet. Then you circle all the spots you want and draw. It then copies a bunch of data to your clipboard. And so on the back end,
Same way.
it's basically just CSV files. And so what we sometimes do, if I want a bunch of like strikes and dips while in the field, instead of pasting that into StereoNet, into my Excel app.
And will that bring all the other metadata associated with those spots, like?
It has a very specific set of spots, like if orientation data, but that's something, I mean, we could definitely work into if that was of use. Is basically just CSVs, what you want exported.
The data, yeah, well, we can talk about it more later.
Yeah.
I think we have a bunch of things I want to
Yeah.
talk about, but.
Um, I do have it pulled up. This is kind of getting to Steve's point, and there was a question about this on Jamboree. You can access and edit data on your browser. And so how you do that is you navigate to stravospot.com, go to your account, my data, and then you're able to view, add, edit data to your projects. And so that brings up this little browser window. And from here, yeah, it works pretty similar to StravoSpot 1 as far as adding spots goes. One thing to note, and this also goes back to the other question on Jamboree about who can view data. So while you're under my account looking at my data, you can choose to toggle on or off this publicity of your data. And so if your data is made public, then anyone can view it while they're on this search functionality. So they can search for it or they can view it. So like right now, this is a few of my data sets that are public. And so you'd be able to kind of go on here and see them while you're there. So if the data sets are private, then they aren't going to show up on this Stravo search. So then I guess, yeah, Steve, did you want to look at how to bring in?
Well, yeah, so one of the other things you can do through the web interface is you can import basically a shapefile, old art form, right? And that could sometimes, I'll just use that just to bring in GPS locations. So I've got some archival stuff. I have the lat lawns and the sample name or site names. It could have been stuff from Google Earth that you can export to KML, turn the KML into a shape, and then you can put that in. So if you have some of these things in other formats, and when you're doing the shapefile import, if there's a bunch of data fields in that shapefile, you can tell where those go into Strava. And so there's quite a bit of flexibility there. And I think it's really useful, especially for legacy stuff. If you're trying to get some legacy stuff into a project to combine with your new stuff.
I will say on the other end of that too, while we're looking at the StravoSpot website, when you're on my data, this is one way that you can download and export these projects. So you can download just like a field book, which is just like a PDF with everything, but you can also download your shape files, your KMZs, and your strat sections and a few other options that you may want. Another thing to check out is versioning. So when you're uploading all of your data sets, they're not always completely overwritten. You do have these versions that are being stored on the Stravo website. So yeah, a lot of the stuff on the website is pretty straightforward, but yeah, knowing where my data is. Also my maps, this is where you can go about loading in your own TIFFs to use on the Stravo app. And so these, again, you can have your own private maps or like, you can make them public. So like we use this at camp of you can have this custom map, it's public, and then you can share it with people and they're able to map to their iPad. So yeah, and then I was gonna share, we're gonna see if this works. Okay, great. Now we see my other screen. Hopefully. A little bit slow, but now you're actually seeing my iPad as I'm navigating it around. This is to answer a question about whether you can color spots. The answer to that is yes. You can do these through either geologic units or through tags. Right now, these are all based on geologic units, but you can also color, so we'll move over here a little bit. You can also color like polygons. So if we add one, say you're drawing in a unit, draw, if you add a geologic unit to this, it's then going to be colored as that assigned geologic, a bit slow. It's going to be then colored as that assigned geologic unit. So you could make a whole map using your polygons colored in this way. The other thing that I was kind of chatting about a little bit over here is this functionality with StereoNet. So if you want to export some of these spots or these measurements to StereoNet, you can go to the triple buttons, lasso spots for StereoNet. Oh, this is quite delayed, but it's fine. And then circle whichever ones you want and draw. Then that all that measurement data then gets copied to your clipboard, which you can then paste into StereoNet, or as we were saying, it is a workaround if you want some quick Excel data, you can just paste it into an Excel app on your iPad. Yeah, so does anyone have any other questions right away about the Field app? Yeah.
Good question about the public thing. Can you toggle on and off different information, or is it like everything public and or nothing?
Right now it's just by project.
Okay.
Yeah, it's not per data set.
But you can move data from one project to another. That's my mistake.
Yeah, if no one has anything else, then I guess we can go right into our Strabo micro little walkthrough. I guess, did anyone have any success downloading Strabo micro?
I was sort of in the same spot, man. It's like I downloaded it, all of it.
Same.
Okay, this is very good to know. I will be.
I didn't try any older version, but the newest one.
Okay.
I tried one older version.
Okay, that's very, very good feedback. And I will be emailing some programmers tonight. Beauty of having this. So maybe we'll have it working tomorrow. Who knows? The time difference might work out where they have a few hours to do it.
It's Saturday.
Oh, you're right. Saturday.
Your program, so it should be out.
I think they're looking at the weather conditions here and they're like, oh, they're not gonna make it. Still here. Yeah, but you're recording it or not?
Yeah.
Oh, so we will post it, right?
Yeah.
Even the
We may have to break it into segments,
Okay.
but we, yeah.
All right, so this is going to be a little bit backwards. So first, I'm going to show you kind of a loaded demo set and some of the options you have there. And then I'll actually just do a quick walkthrough of how you can go about bringing in photo micrographs and associated micrographs. And so this is just kind of will be pretty repetitive of what you saw this morning, but it is nice to see it all kind of connected. So here we have this reference micrograph with associated micrographs, and you can always open and close these. So you can see that this particular micrograph has quite a few associated micrographs. We can also see, if you look in this lower part, it's kind of slow. If you don't want the associated micrographs there, you can toggle them on or off using the little icons over in the navigation pane. So if I hit that, might be a little slow. It should turn off on the photo micrograph. So you're able to turn those on or off as you see fit. So again, this is kind of a repetition, but we have these associated micrographs that move down this hierarchy from this main spot, this sample 17 SD23, and you can see your course calcite phase maps and your microprobe WDS. And this microprobe data does have some of these associated files, which you can link, and you can just add, or you can just view by simply clicking the link in the application. So on the right here, we do have our notebook. And so we can go about adding data in a few different ways. So you can add data to your entire photo micrograph, or you can add it to specific spots. So you can do that by either selecting your data type that you'd like to add. And then a lot of these have pretty specific forms that you can go through, or if you have a data type in mind, you can just search it and then choose what you want, and then it brings up the window for that specific type of data. And then over here on the right, we do have how you're adding points, lines, and polygons to the map. Again, this is very similar to how this field app works. You select a spot and then click where you want it to go. You can add a spot name. And then you can choose the color. So this might work into your workflow if you have different colors meaning different things as you're going along. You can also use some of the navigation up here to zoom in, zoom out, and measure distances across the micrograph. Because again, we'll see when we're bringing in some of the photo micrographs that you are scaling these. So over on the left here, again, we have this navigation pane. Right now, we're looking at the sample of these are based on their respective sample that they're coming from in that hierarchy. So this is where you can organize things based on whatever works best with your workflow. Here we have spots. So if you're looking for a specific spot, you can click on it in the spots navigation pane, and that will take you right to that spot. Here we have tags. If you click on the tags, it shows you every spot that you have under that tag. And again, you can click on any of these, it'll bring you right to it. Another way to view the tags is if you hover over any spot that has a tag, it's going to pop up and populate all of the tags that are there. So now I am going to close this project quick. That's probably not good, but that's fine. And then just show you how you could go about just starting a new project. Again, if you want to open a project from field data, you click this, and then you're going to basically have a selection of all of your projects that are currently on the Strabo server. You can also open local projects, so that's something you have saved on your computer, or you can open shared project files. This is a bit interesting. So if you open this up, you can share these project files using just a code, and it's a little bit easier than trying to say email or share these sometimes pretty large Strabo micro files. But to open a new project, you simply open new project, give it a name, and then populate these fields. Again, it's good practice to populate these fields as much as you have the information for. For this example, I'm not going to do that because you don't want to sit here and watch me type for a while. Just give it some data sets. So then once you have that all set up, you can actually begin to load in some reference micrographs. The ones I'm going to be loading in now are actually provided by Matt over here, so they're quite lovely. You might be able to give us a little bit more information on them. So basically you navigate to the image you want to bring in. Like open, next. Then you select what instrument you want. While bringing in your spots, I realized a bit of an oversight, which is we don't just have an option for like a camera. So we have close enough. I'm just doing scanner.
Scanner, I mean, it's a macro photo of a thing. It's just faster.
Yeah.
It's the same.
One thing to note is you can find instruments in a database. So you can have these preloaded. Unfortunately, the only way to get these instruments in is to basically contact one of the programmers and have it put in. But once one of these instruments is in for your institution, it's just in there, and then you're able to, I can just, as an example, you can choose one of these and then it will populate this next field with all that instrument data without you having to really do any typing. And so it is pretty convenient, and it is pretty worth it if you're going to be adding a lot of this data. What's the name of this one? It's AT80.
So the mount would be like TL 89-, I don't know, something like that. So it's the background is we have like a project on a volcano. You give it an index number for the project, and then the mounts, every mount we make with different Tephra will be numbered with that index. So this would be the first mount, and it has multiple samples on it.
But we can bring this reference micrograph in. You choose if it's unoriented, or if you have the orientation data, that's where you would plug that in here. And then you're able to set the micrograph scale. And so there's a couple ways to do this, but I think the most common way is going to be tracing the scale bar. Correct me if I'm wrong, it's about
It's an
20.
inch. The whole thing at the round is an inch across.
Okay, I've been doing it, it's about 24.5 millimeters, 25.6, okay.
25 would be close.
Okay, so you can just select that line tool and then drag your line across. Or if you have a scale bar in your photo micrograph, you would do it on that. And then you hit finish.
This is where some understanding of like instrument coordinates could be really useful. And like
as your-
Free PMA has this utility called Picture Snap,
Okay,
which essentially does this translation between, image pixel coordinates and physical positioning of the instrument.
okay.
And from that, you can actually drive the instrument to a location or digitize positions for analysis. But it just creates a little coordinate file
Yeah.
that goes with the image that essentially lists, this set of this, XY pixel coordinate equals this XY, maybe Z
Yeah,
stage coordinate here, and then there's another control point over there. And so it's kind of got a little georeferencing file.
okay, that's,
And so you could just import that potentially, and then it would instantly have.
yeah, I'm following now. So like when you're in Strabo Micro, this would then have your coordinates that are associated with your microprobe. And
Right,
so
and then
each
if you
file-
had a file with 27 microprobe analysis positions with the coordinates for the instrument,
Mhm.
you could import that, and then presto, they're just on there.
Okay, yeah, that would be very nice.
No entering them one at a time. There it is.
Okay,
How would you envision something like that to be archived?
Yeah.
I mean, that, to me, it's
I mean, I
a
think.
real challenge.
Yeah.
I think at some point, there needs to be an image associated with it, and sort of the way I thought about this, you have an image with your control points identified on it, and then you have coordinates to those control points in the different instrumental contexts that you move to. But at some point, you know, you're finding the location of a physical thing in your sample.
Right.
So that's gotta be.
Right, you're talking about with multiple instruments, then you have to have 4 different coordinate system.
Well, yeah,
Layered onto the same image here.
yeah, if you go from a microscope to an SEM to
Yeah.
a laser to, you know, whatever else.
I think this implementation is actually the better global solution than the Pro-Pre PMA, which is like that works the day you load that into the stage, but then once you take the sample out, that coordinate system's not relevant anymore.
Yeah,
And this
actually,
like
you could
mapping the pixel coordinates on an image that's
Yeah,
permanent could be, but this is a million, I mean, this is the best scene, but I mean, this is
Right.
a hard, it's still not a problem.
Right.
By having you know, you can create able of your control points even per instrument session, because every time you load or unload something, those positions are gonna change a little bit. You can get it back in the same folder, so you could have those positions like re-referenced based on, you know, that separate table per analysis session.
right, and if every one of them has in common the same image, then they could all be interlinked.
Yeah, it couldn't even be like a master, because like every mount or slide is a unique sample aliquot. And you could basically have like, get in the habit of having reference marks on the mount. That then you have a file that says for this mount, these are the XY coordinates, and then everything else is in my reporting is relative to that. But it would be the data. That would be hard because like that's not how any of the software is set up to deal with it.
Right,
I
but
don't know.
GIS does this kind of thing all the time.
I've seen an AGU presentation where someone
Yes.
had a GIS application doing this,
Yeah.
and it was like,
I mean,
That's what
A lot of
the
work.
system is doing.
Yeah.
They have fiduciary points and that's how. they-
yeah, part of the problem is every instrument does it, or every model of instrument does it a little differently. And so I've seen people do it, you know, between their SEM and their, you know, IM probe or whatever, but, you know, having like a generally applicable system is just sort of.
Yeah. Well, yeah, another dream item would be, you're sitting at the instrument. The instrument software is on this screen, Strabo Micro is on this screen, and we use an instrument API and say read coordinates from instrument, read image from instrument, and it just sticks it in.
I don't know people's experience with Pro-Pre PMA, but I rarely use picture snap, or if I do, it's just for like a big overview scan of everything to just help get me oriented, because I find that you spend a lot fussing with getting everything right when you're paying by the hour. And honestly, I've worked with enough microanalysis.
So
I just am faster driving around, and I end up just taking a Sharpie and and marking it, which is what this is.
what I've done in my lab is I use picture snap all the time.
Yeah.
And I made a frame. So essentially, I have for the thin section, I have in CorelDRAW a frame, right? And then I put the scanned image of the slide into that frame and adjust it to fit. So then I have sort of, my image is pre-calibrated.
Yeah.
Partially pre-calibrated. It's usually pretty close. And so then when you go to the do a couple of spots, tweak it so that it's just so, and so you don't have to go finding the coordinate from scratch every time.
Yeah. Like the whole mount folder.
Yeah,
And that just gets you, like, that's what it's useful, it's one image, but like, I'm more thinking like when you go to a laser, a lot of the modern laser instruments will let you bring in your BSE images.
yeah,
But like, if you spend the time referencing each of those, like that's time you could just be picking spots and getting data. And I think this is like fundamentally, I don't know what people think. I think this makes more sense. Like, I just want to have this app open on another computer screen. It's like, yep, I'll put a laser spot there. That's my laser spot. Moving
yeah, I
on to
mean,
the
you
next.
just click this on the two different apps.
Yeah, and then if this JSON format has a way to be archived with the images, like that's then could be a really brilliant. I mean, I use PowerPoints to do the same thing that this is doing. This is way more elegant. Yeah.
I don't think you need anything else, really, right?
No, this could be really good.
You'll have image coordinate system you referencing your points. That's why you need to see where the data coming from.
Yeah.
That's it. What else are you gonna do with this?
Yeah, we don't need to know the XY coordinate. We need to know where on that which grain on that sample mount were microprobe points 1 through 5 analyzed
Right.
on.
And if you move it to next instrument, you just.
Yeah.
You're going off
Coordinate
one
system.
mount.
Right.
I don't care.
Right,
Yeah,
I mean, there are applications like, let's say you have a SID section. And you can pre-calibrate that for approximately for the stage coordinates. Send that calibrated image to a colleague. And then they could just on their screen pick points on the picture sitting in their lab to tell you where they want you to analyze when you actually stick the thing into the microphone
But
later.
it's not archiving. It's
Right.
data archiving.
And they can do that with this too, actually.
Yeah.
You could send someone a BSE image of everything,
Yeah.
and then they could annotate where I've done this actually with
Yeah.
probe data where I've this mount, I do on an SEM a bunch of BSE images, and then I send to an analyst, I want points on these crystals.
Yeah,
And then this is the number I want them, and it's easy. They just get on there, they find the grain and they drop the points, and it's
yeah,
fast, so.
but then you still have to program the points into the instrument rather than just dumping a file that it can read and just go there.
Yeah, but then you still have to trust that it's moving to the spot that you want it.
Well, yeah, you always have to do a tweak. You know,
So,
there's a crack there or something.
I would rather just physically drive it myself. It'd be way easier than
I think
going
it's
back and
faster.
checking it
Yeah.
yet again to make sure like, oh, there's not like an inclusion right where you hope that there wasn't something.
Yeah. But
So they have it. They don't need anything.
I don't know, this is beautiful. Yeah, this could be really, like, I need to get comfortable with the workflow and like trust like its longevity. I think is probably the thing that's holding me back, but like it's the best implementation I've seen of what is, I think, one of the biggest problems in microanalysis, not just for Tephra, but like diffusion
Oh, yeah.
studies and
Oh, yeah.
everything else. This is really.
And ultimately, you have your image, so it has the pixels, and you have your XML file, so you can manipulate this any way you want. So you don't need any.
No, you're all good. This is all super great and super helpful. I do have one quick, though, I can show you how to add the associated micrographs. And I think this is a good thing to walk through because you can see how the scale is kept from different micrographs throughout. So to do that, you just hit the add button over in this navigation pane, add your associated micrograph, choose which one you want. And then here, again, you're going to have to add instrument information. So if you had been doing sort of the same type of micrographs, you can just metadata from the previous image. Or in this case, you're going to add a new instrument type. And then again, you could either have the preloaded instrument data or you'll have to fill in your own. And then you can add all of the settings that you used on this image to keep all of your metadata in one place. So then that loads in. What's the name of this one here?
AD 4599, doesn't matter.
I think that's right.
Might have to be right.
Anyway, so then you have two options to locate this micrograph within the reference micrograph. And I think one of the best ways, I think the better way to do it is locate as a scaled rectangle. And then you can stretch and drag it. And so basically what's going to happen is you're going to get this pop-up where you have this little window and you have your associated micrograph that you're able to stretch and drag and can rotate if needed. And then you find where it was at on your reference micrograph, get it all nice and lined up. I'm not going to do such a good job here, but you get the idea. So you get it lined up, you hit finish, and then that micrograph is now on top of your associated micrograph. And then when you go here, you have the same, it's already scaled to the reference micrograph. So yeah.
So I do batch image acquisition of BSE images. So what I need would be a way to basically annotate on that first slide where all the images I'm taking are.
Okay.
No.
This is where stage coordinates.
Well, yes, but, well, we could,
mean,
I mean, you can
basically,
coordinate or you can draw a box that
Yeah.
just remind, and I can have it like pre-tagged that image one is here, and then when I.
20 images that are all 100 microns across and you have the stage coordinates. It would just all come in.
Well, there is one potential workaround, but so we have a brand new Joel SEM, and when you put your sample under it, it takes a picture of the whole thing, and then every image you take, it automatically overlays it on that area. So then you would just have basically this, but all your spots exported. But not every instrument has that.
Yeah.
Like we can't do that on the Kamiko, but I take this image and I just go and map each one of those holes. It would be a 9-hole in that case because it almost perfectly fits. Was where you can actually just take a broad scale image, but I actually haven't thought about exporting that image yet, so I'm missing a step too.
Actually, no, yeah, it's cool though.
Yeah, I mean, I mean, there's so many things that you could do if you want to go pie in the sky, but you've got an API. Strabo Micro drives the instrument and then archives the data that comes off directly. No other users are interface, nobody's typing anything wrong. I mean, that would be amazing, but it would be a lot.
I would like to say we have one programmer on Strabo.
Yeah,
Micro.
I know. You would need to have some of these.
And it's really.
I mean, it would be really interesting to, play through the whole thing, but I always, am concerned about to think of something like this as an archive. It's not an archive. And
Yeah, it's.
the work of data management is very well defined as there's lots of requirements and on sustainability issues, on transparency, and that's sort of in my presentation for tomorrow. So there has to be either a consideration of turning this into a repository, which requires a from certification to all kinds of things, or you need to think of a pipeline to bring those data that go public, that need to be archived for sharing into a repository.
Right.
And that brings me back to this networking
Right.
and leveraging capabilities.
Right, yeah, and when you put that into the archive, then it would be linked to the geochemistry, it would be linked to the samples, it would be, right? So that would connect to CSAR, it would connect to EarthChem. And
I mean,
and
the
EarthChem
CSAR connection can always happen, you just have to have the IGFN in there and it's resolvable. But it's just the sustainability. If you call yourself an archive, you need to guarantee that the data, that you have a plan how the data in 10, 20 years is still available. That's, a fundamental requirement.
I would say, like, if there was a way to, just not to, I mean, Strabo Micro, I hope Strabo, I love Strabo at the very best of it, but like, is it gonna be here in 20 years? I don't know, like, I know the state, we can't know what NSF is gonna fund, so like, if we could think of a way to have an output from this that was not reliant on that software. I mean, that's like even a printed PDF of it all. Then you can visually see the link. Like, would it then show? Would you be able to know that image where it was on the
Right.
Would you be able to track the nesting?
I mean, what this software of the NASA project does, it creates bundles, it creates packages that have the spatial reference file, that have the actual image files, that have method or instrument metadata and so on, and it's all packaged. So it's something to think about. Is that the way we want to approach this to make,
So I want to see this PDF. This is exciting.
So this is just. So you can file, export, you can export it as the .json or as a PDF. And this PDF it's a little clunky, but I mean, if this is what people want, we could definitely clean it up. I think these are all linked to, so you can click on the sample. It'll take you to it, and so these are all kind of, it's obviously a lot clunkier in the PDF form, but they're all still within this hierarchy.
How does that work with the nesting? Like, can you then know, like on the image that we just were bringing in,
Yeah,
is there a way to know where that one BSC image, which, you know, you can see the little box, like, is it a link? Like you can click on it and it'll take you to the page where it is, or is it?
no, it's
Okay.
definitely not to that level, but
Yeah.
I mean, this is good information, because if that's what's holding people back from Strava Micro is just a longevity of the data set, I mean, that's definitely something we can.
Yeah, because like this to me is like, in terms of the archive, it's not super critical that everyone reading the paper can see exactly where every analysis was on every image. It's super critical for someone who's going to do a future analysis on that mount. If someone did a big micro project and I come along and want to do a laser project, I'm going to have to recollect. I know what points came from. And so I don't need to see that when I'm reading the paper. I need to see, actually physically have that with the sample. So if it's analog, that's fine. If it's, you know, preserved file format, that's fine. But like if we solve that like that, yeah, that would be, analog is just a lot of binders of paper that I have in my office that I'd love to not have. Yeah.
I think the way the database works, right, internally you georeferencing everything. All your images, they actually get georeferenced.
Yeah.
Because you have 64-bit system, so you have a limit of digits you can assign. So it's not a problem. The problem is like maybe overlap first two images at that level.
Yeah.
I think they're reporting internal.
Yeah.
Yeah, we could talk about this. It sounds like the PDF export, like with a little more features, could actually do.
I was gonna
all
say,
this.
it's just definitely a part of the system that I don't think anyone's really taken a look at. And so it's just figuring out a format of exporting it that is useful. I mean, because on some level, it would be useful to export this data. If someone doesn't have Strava Micro downloaded, or you want to email it to someone, like it would be nice to just have a quick overview.
Matt, do you see a benefit? I mean, I know you were gonna keep going and continue embedding and getting.
Oh, I wasn't, but you can, yeah.
And presumably you can link geochemical data to that point.
Yeah.
Would that be a one-to-one, because like a 1-point-to-1 analysis thing, or you always want to look at it in a spreadsheet with other?
At some point, the analyses are given numbers, and I just need, like, if you can click on the labeled analysis number and it takes you to this row on the spreadsheet, cool. But I mean, mostly it's just you need to be able to know what the number is and match it up. So then you go and enter, when you're entering your data file, you know what everything's matching up with.
There is one thing, like, you know, when you're running probe data on andesites, right? You have tons of microlights.
Yeah.
And the beam size, like some labs using 20 micron beam, right? Some labs go 5. And you actually like covering different areas during your analysis. So there is some value to understand what you actually do.
I was actually gonna say, the functionality is actually the reverse. I don't think I would very often be looking at the image and want to know where the chemical analysis for that spot was. It's more that I have a chemical analysis and I want to know where that came from.
Yeah.
So if your analysis numbers were recorded in this as a digital searchable object, and I have it then in a spreadsheet with all the analyses, I'm like, oh, I want to know what's this came from, and I could just go into the search and it would take me to the BSC image where that was. That would be, that's
Right.
would be
that's
very
what I
useful.
interpreted. If it's microlytic, you might say, now I understand.
Yeah, there's a population of weird points. Oh, look, they're on a grain that has different mineralogy.
Yeah.
Okay.
Errors
Really hear
get
what
a bit higher than usual. You like don't blame it.
Yep. Or it's on a sample that's got a weird glassy texture, and you're like, oh, that's thing's devitrified and that's why it's bad. And then you throw it out. But yeah, this is great.
Instruments, sorry, it's a little bit changing the topic, but like what happens very often, instruments get upgraded.
Okay.
So everyone.
Instruments get upgraded or they change configuration. And normally you want to track it somehow. So just simply developers adding instrument, it doesn't help you much because you really want to have like fine tuning to the instrument. You might have a like release 1 update when you were using instrument.
Well, isn't that in the Earth Chem plan? That when you put data, there's like which version or version are you using? So like for our stuff, like from 1996 to 2015, we used 3 spectrometers. 2020 or 2016, we switched to 4 spectrometers, and then we completely reconfigured all of our like analytical setups. And so I didn't realize this at the time, but like my whole PhDs was 3 spectrometers. My whole postdocs was 4 spectrometers. Like I didn't think of like that was the dividing line, but now trying to get data into EarthChem, I was like, oh man, I gotta like go back and figure out like what was like when did we switch?
I mean, that's, yeah, I mean, often with the historic data, you wouldn't get that level of information. That's really cool. If you're trying to do that, like, it's, I think that.
Right, it's like, that's why this set has much better precision than that set.
Yeah.
Yeah, I mean, that's
Yeah.
what matters to people
Yeah.
who want to reuse the data.
So I guess point is you want to give a user control to instrument configuration somehow, if it's possible.
Like, just being able to save the like, blanking on the word, but being able to save the instruments instead of having to go through the PIs and go through the.
Right.
Well, yeah, I mean, I guess in some way that's like, if we're producing this stuff for EarthChem, like
Mhm.
that, you know, NMT, you know, SP3 spectrometer, you know, 3 spectrometer setup, like that is something that is known and available. Like that was the setup for 20 years. And then, you know, the next 10 years was, you know, a different setup.
But does it have date? It's like you might accidentally overwrite your sample ID on a different session 10 years later, but like
Oh yeah, we do that too.
on a day, I mean, it's sometimes you still override a sample ID, but that's just that's a primary mistake. Can't do anything about that. But if you, it happens. But yeah, if like when you're adding analysis spots, not BSE images, I don't really care as much about, but like, yeah, if you're adding analysis spots, if it's just associated with, if you can say I've added spots 1, 2, 3, 4, and 5, and they're this date, doesn't need to be that precise even.
I mean, it's gonna be, if you're adding just spots actually on here, it's gonna be saved in your
Perfect.
spot metadata.
Yeah, and that then will lead you to the analytical file, which will be stamped with the date that the analytical file was generated, and you'll be good. And then hopefully you have notes of what your instrument conditions were on that day.
The Tephra business, for example, the way you're counting the sodium, potassium,
Yeah.
which spectrometer would
Mhm.
determine what you measure, like you get a little bit too high to maybe take a look at it. So that configuration should be available at some point.
Right. And yeah, it'd be nice to have it, you know, like you have that library, right, where you
Yeah.
pulled up the pre-programmed 18 instruments or whatever.
Yeah.
To have a local configurable library that you make yourself.
Right.
And yeah, and then you have, okay, I've got 4 ways I usually do BSE images, like that.
I mean,
And they're just all
But they
there.
want to share it, that's the point, because students, they really don't have the.
Yeah.
The granularity.
all of those instruments that are in there, it acts more like a template. So it'll populate the instrument fields, but then you would be able to adjust it as you go, or you would be able to save. So say you have like these 3 SEMs or these 4 SEMs, you could save that as separate things in your same
That's it.
institution.
So I think that's-
But yeah, you're able to change that as an individual once it's into your fields. I'm not entirely sure what the decision was behind having it go through the programmers, but I think it might just be a bit more of a check on the instruments just to make sure that it isn't getting populated
It's
with
just,
something.
again, if you had everybody doing it that way, that it's so long. and
Yeah.
It's slower.
And people are
Beginning.
check if an instrument's already this way, they're gonna go through. Already, yeah.
In the Argonne Geochronology lab that I work with, sanidine is spelled 8 different ways.
Yeah.
There should only be one, but it's like someone's writing it down in San or San-S, or they spell it incorrect. So, you know, same mineral spelled a bunch of different ways. And so you just have this huge drop down, or ground mass concentrate.
Yeah.
Another question, so it looks like everything is I think I know the answer, nesting images, you nested an image on that scan. If you nest a sub image, can you nest it on the smaller BSE image?
Yeah.
Okay, so it creates that, okay, cool.
I'm only doing this because I have the one just at the ready. So then this is your next one. And you can just, so that one I can steal the data from the nested one because it's the same instrument. And so all that would be populated. Oh, I could have let you play the I Spy game.
But there's the option to annotate that other image with like just a rectangle.
Yeah,
just like a red box,
definitely.
Temporary holder.
So-
When you get your images, yeah.
Yeah, you could definitely, so it's trickier to see, but this is here, but you could definitely add a polygon to this. Before you have that image there, and you could say that this is where I'm going to be.
Yeah. It'd be nice to have like an outline feature, so when you.
Or like a set rectangle feature, I think that's probably just a little widget add-on, because I mean, in the world of imaging, we're almost exclusively making rectangles. So that would be. But if not, this is not hard to do.
Yeah. But yeah, I used to do this in PowerPoint, so a new way to do it on the spot.
Yeah, you can nest underneath this one, but then you could also start a bunch of different, like, kind of branching sibling hierarchies going through here.
It's very cool.
Yeah, I guess, are there any other Strabo micro questions? This has been great. This is a lot of awesome feedback.
Adding like. It's showing the analysis, can you specify like. The 10 micron circle or something like that for, or do you have to sort of eyeball it?
No, I think right now it's just to a single kind of X, Y coordinate. Right here, a little tangent, you can do that actually in the field application of making your circle a little bit wider or smaller around your spot, like plus or minus 5 meters or so, but I don't think that's available in the micro one.
And you can only set the scale to the topmost image. Is that true?
Yes.
Okay. I was thinking, once you get down, go from 25 millimeters down to 10 microns, I suspect distortion is going to be an issue.
Well, you can let's do it on this one again.
So I'm just thinking out loud again, Matt, in terms of using this in the same way that we use the folder to figure out where we're at so that we can, maybe we did laser work first and we have to work backwards to do the code work. Would you bring this to the lab or would you export a PDF?
This or the PDF, I mean, the PDF, if the linking was fully built into the PDF, I mean, that would be pretty. That's what would make it really cool, because you could use this app and have all the ability to re-annotate it and have it saved, then you'd probably use that. But knowing that the PDF could do that for you.
This isn't just for documentation, you actually have to physically use
Yeah.
it to do things. I mean, we have to have it with us, next to us on the.
Yeah, I see what
If
you're.
it's on a computer, that would be awesome, right? 'Cause you're not.
I'll have to test the workflow, but the other thing I was gonna say is anything you can think of to like minimize clicks in the workflow. Even though, like, because you're already gonna be doing a lot of clicking on an instrument, and I don't know, it's just one of those things where it's like the more streamlined the workflow is, I feel like the more likely people will adopt this, like it. I mean, that's where when I get stressed, I just go back to the old analog Sharpie, because I'm just like, I just need to go quick and
Print it out, tear the dots out, call it good.
yeah, but
Answer your question, so you can, I only do the drag one, but you can measure the scale bar and then drag in it. So that-
I have that same thing going
down.
cool. It's good to be the end of my conference, and I'll be happy.
Question is interesting, though. I'm not sure how you would work around that, because basically,
There was no sign.
I mean, if you're looking at these hierarchies of families, you're going from a grandparent to a grandchild and missing like a parent in between. So I'm not sure how you would.
Well, you could drop laser spots on every one of these grains and like that. Instead of image one, you can just put a spot on each grain and label it as a number. And then go back, find that grain, take a BSE image and put it in between. And then you can move. You don't even really need to move the spot to the image because you don't know where.
Yeah.
Well, I guess you actually might know there might be a big hole in the middle of it, but
Yeah.
so anyway, this is great. This is really neat. I kind of knew it was neat in the spring when you demoed it, but I just didn't quite see the functionality. I didn't trust it yet, but I think I might be there.
I mean, this is all, yeah, super great feedback. And yeah, we're kind of at the edge of like beta to release. I think, I'm being honest, I think they're waiting for like GSA to throw like a party and release it,
But like the PDF export too, because then you
Yeah.
can print it potentially.
yeah.
And because maybe you're going to a national lab and they won't let you bring your computer in, right? Like that's a real. So like there's a reason to be.
Can you print an entire package, one copy of Strabo Micro, give it to somebody on a thumb drive and they walk into their lab and load it into their Strabo Micro?
Yeah, absolutely. So you can save these as local files. So you can just save it right to your desktop or like whichever file you want. And then you'd be able to put that on a thumb drive and then you open up a local project. So for a while, we didn't have Strabo Micro on the servers. So it was all local stuff. But yeah, so there'd be no reason you would be able to do that.
This is cool. So you said there's just one developer, you're taking a lot of notes, we're making notes. Well, you'll capture all those. Is it best to like work directly with the developer if we have specific uses? I mean, I know Strabo's been super good at working with individuals, with agencies, territories. I don't know why that is. It's super generous, and wonderful, but it's awesome. I mean, is that something Strabo Micro is also willing to do?
Yeah, I mean, absolutely. So I'm not sure how familiar you are, but it's Doug, Basil, and Julie are the main 3 PIs for all of the Strabo ecosystem. And Julie is kind of the main PI for Strabo Micro. And then it's Jason Ash that is the main programmer for Strabo Micro. There's a programmer and a half on the field app, but that's kind of how it's separated. But yeah, if this is something that we're looking to pursue, we definitely be open to having we do weekly Zoom meetings, and we'd be open to doing something like that, or just getting people's emails allowed. I know some of the sedimentology folks have been talking a little bit about having just an open Slack or Discord channel of that sorts, but I think that's more towards the end when there's a lot more users trying to figure out how to use it. So I'm not sure at this stage what's the best, but yeah, the short answer is yeah, that's kind of how the Strabo team works, is we're very willing to work with people that are giving back really good information and that are actually going to use it. So yeah, I'm taking notes too and was going to send them right to Julie.
So much. All right, are there questions online?
I think Bill's snoring.
Yeah.
My grandmother was.
Speaking of we're pushing into our social hour. So I guess I'd recommend that we clear the room and go downstairs to the bar and have a beverage. Kirsten's hosting the social hour, so thank you so much for doing that. And I think we were going to go to there's a couple bars in this hotel, and the one that we're going to is called DAD.
Oh, yeah.
I thought that was this big one here. That's probably
For people who are online.
we can't give them drinks.
Right, but I mean, for tomorrow, are we going to launch Zoom tomorrow morning when we meet and update everybody?
We can do that. I mean,
Or could we put it on the Google group mail? We need somewhere to communicate to do it.
How about if we still just say we welcome you to page? What?
Something good, because then people will need to.
We have time at some
Logging
point
in
and really.
Zoom
You want to start that section stuff, just because we've been doing a parallel effort. Ours is very much integrated in this SQL database, integrated into that, and also the export. And I know that Doug and them know this because they talked to us when they did the first export. But that's really what it should be. Field work and work on.
More than trouble, Mike.
That I would say is probably the most successful thing that made us was the ability for us to be taking our notes in the field
Maybe we don't.
and then exporting them straight into the database. And if they're not a perfect match, that's fine, but the fact that we can report those fields we need to report in the field and then have them in a tabular format to go into, because our reporting requirements we get out of the field, we need to upload it to the database. And then, really what it is I want to get out of the field, export that, and then be able to look at that and edit it in the evening, make sure everything's good and clean, with the least amount of like fussing. And the big thing, the big change we're going to make in the next 6 months is basically inserting the layers into as one of our tables that we export. And so I've thought a lot about programming it.
So I think they probably.
And then Cheryl, we said Cheryl, and Christy and I said, yeah, they would really carefully work out like these are the required fields, like minimum required fields. We don't do depth top, depth bottom. Because we're like depth is just derivative on